Okay, this is weird. All right, that's a little bit better. Because I'm wearing a light colored shirt, the camera's freaking out. It's freaking out. It doesn't know what to do. Also, what is going on with that shadow in the background there? Hold on just a second. And we've got all of our audios, right? Yeah, we do. Okay, good. All right. There we go. That looks a little cleaner. And I think we're ready to get going here, so I'm just going to press the go button. Go! Well, hello, and welcome back, everybody. So we're going to continue on with what we've been doing, which is to do what must be done every day. So, let's see. Oh, goodness. There's a whole ton of stuff that I've got open that I ought not to have open. All right. What's this one? We can close that one out. Can I close this one out? Can I close it out, please? Please, can I close it out, please? The answer is yes. Yes, son, you may close it out. Yes, thank you, Daddy. All right. How about this over here? I don't remember where we were, but the good news is I don't have to because it's all right here. There was obviously some things that were going on in there. I don't remember what they were, but we're gonna get back to it and figure it out. So where we left off was WASM DPP wasn't working, and it's our only chance without having any documentation or anything else to know how we need to do these things. WASM DPP has to save us. It has to. Help me, WASM DPP. You're my only hope. So that's the thing that we need to most heavily focus on. Now remember, before you ever do an npm install, remember, npm install does not do what you think. You might think that it would install, for example, the latest version of something. Oh, nay, my friend. I don't know what it does, but as long as there's node modules there, it's not predictable. Okay. Oh, and I need to update my alias to be npm safe or something like that, and just get in the habit of that. Yes, I accept the risks. All right. Similarly, now, and my hope is that we actually won't need these packages at all. That hopefully, fingers crossed, there's actually going to be a way that we can just use JSON and a gRPC proxy. The gRPC proxy may have to have a lot of information in it, but we'll cross that bridge when we get there. And then that could be server side too, where, you know, if you have to have 10 megabytes of struct declaration files or whatever. I mean, it's a double-edged sword, because on the one side it could take longer to get it updated, but on the other, you know, on the other side, you could reduce the browser load to something that's reasonable. I don't know how they do it. I don't know how they do it. I have a sense that it may not be as simple as something can arbitrarily convert from JSON to gRPC. I have a sense that it's going to need an actual schema. It's going to need a schema. Now maybe we can just load a protobuf file at runtime and say, hey, fetch the new protobuf file as needed. Maybe that could work out. But we'll see. Anyway. Oh, and I forgot to rumrough node modules before I installed that again. So let me do that. Never not rumrough node modules. All right, now the other thing that we need to do, never trust npm install. Not even once. Never, ever, ever trust it. Okay, good. The version that's installed is the version that we wanted. And I think this is the version that we wanted. So, with that, I mean, I don't have high hopes on this. I have some hopes on this, but they're not high hopes up in the sky hopes. Well, let's see. Okay, what is this nonsense? Jojo, what are you doing? Why are you posting memes in a channel where we actually get work done? Why? You know, the joke used to be, the longer a chat goes, the more likely it is somebody's going to call someone else a Nazi. And now it's, well, the channel's just dead unless it's full of memes. Okay. I'm scrolling back. I'm trying to find the right place. And then, of course, the live scroll update pushed me completely out of where I was trying to be to some other place. So let me scroll back again. Come on. All right. That opened in the wrong browser, but whatever. So this may be the bit of information that we didn't have that we needed. Okay. What in the world? That is so confusing. I don't know what to make of this. Is this saying that there's a thing called .default? I think that's what it's saying. Yeah, this is messed up. Messed up. I get angry when I see stuff like that. Y'all know this. Y'all know me. You know I get angry. It's no secret. Okay. So... You're my hero. Let's unite together to make software great again. Muzga! Well, thank you very much, my favorite tardigrade. Now, we are streaming on the Dash channel, right? I just want to double check on that, because we're supposed to be streaming on the Dash channel. But my favorite tardigrade, I know you pop up on my regular channel. Okay, looks like we're all good. All right, yeah, so with this thing here, it looks like what we're going to need to do is maybe we'll just call it WASM DPP. And then we're going to need to do await WASM DPP.default. Is that how this is going to work? And then we need to call let DPP equals WASM DPP. I mean, it may be that this is just how you have to do it, but boy, does that look tarded. Is that really? Oh, no. So we call .default? Oh, flippy dippy. Okay, so this won't work this way. We have to go do in a main function. It seems like it should just do that. Like, okay, here's how to solve this problem. Just have a regular export and have an init function that's async, and then you can just do await the thing async, because this just looks janky. You know what I'm saying? This looks wonkadonk. So how about we just create a function called init? Whatever. It won't matter. It won't matter. We won't be using this that long. Just enough until we're able to create documentation and then implement the protocol. All right, so that doesn't exist yet. That's fine. Oh, right. And then we need to copy over -tx because otherwise we're going to have the wrong version because I didn't publish that yet. Although I think we're ready to, but I wanted to finish this out before we did. All right. So, you know, I just don't have a lot of energy for this one tonight. I'm going to give it an hour or two, but I'm not. Oh, yay. Oh, wow. Okay, cool. We're getting somewhere different. I think that's a good thing. I'm not sure. Oh, no. It's just we're not on the right branch over here. I need to delete all those branches. Bunch of branches. All right. Well, we uncommented some code and it didn't fail right away. So I'm going to count that for the win. You're a wizard, Harry! Do magic! That's what this function is supposed to be, I think. Oh no, asset lock proof, we still, I don't think we have any idea how to get that yet. Or maybe a very, very vague idea of how to get that. I don't think we have a strong idea of how to get that yet. But that's okay. I don't think we need it in order to do this bit. All right. So if we can do this, it is cause for rejoicing. If we can do that right there, that will be cause for rejoicing. Oh, whoops. Oh, did I not retype it? Oh. It's my favorite thing to do. It's just retype numbers. Good old 53-bit integer. Everybody loves it. Now let's go ahead and run it and see what happens. Oh, okay. So again, wallet key is defined here. Yes, I did. I did mean you at 53. Yay, let's do this. Yay. Oh. We'll see. So what we're going to have to do here... Let's just try this at random and see if it works. Okay. So we may have been given misinformation here. Or not misinformation, but just information that happens to be wrong. All right. Okay, fingers crossed. What? What? It worked? Oh, I don't know whether I'm happy or sad. Now I've got more work to do. All right. Well, I know Ryan's happy. You know, I was just going to be like, stars, not aligned. Can't do it. I am curious what happens if we just comment out that await. It probably, I don't, yeah, this is kind of, it's kind of weird. Okay. All right, so what we don't know is where this identity thing comes from. But I'm wondering if it's not supposed to be the identity that we pass in. But we can figure that out a little bit in a little bit. All right, so DPP keys have been returned. So whatever DPP keys are, we've got them now. All right, so we kind of know the rest of what we're supposed to do. We're supposed to get an asset lock proof. It's not clear to me what that is. It's kind of, sort of, I have a vague understanding of how to do it. It has something to do with, oh, see, this is the problem when you let go of your demons and you just have a good night's sleep and you just really allow yourself to rest, then you have no idea where you were at and what you need to do next. I think, did I not? Let's go check and see on this repo. All right. Instant lock. Create chain asset lock proof. Instant lock to buffer. So a big question here is, what does it mean by instant lock? I think this is back in the Rust code. The proto files are the schema, right? Yes. Kind of. In that, yeah, if everything goes swimmingly, then yes. But it's protobuf seems to be like a meta schema where the protobuf is a macro that you then use to generate a language specific schema. But regardless, if we have the proto files, then yes, the idea would be that we could slurp them down and hopefully, fingers crossed, at runtime, be able to dynamically generate them. And if not, then you just need to recompile a binary and redeploy every time, which we're going to have a deployment problem here very soon. Because people are going to have deployment fatigue, and what we need is a click button auto updater. Okay. Identity facade. All right, so I'm kind of interested to know. Dang it. Is that going to kill me? No, it didn't. Good. This shirt is much warmer than you would think. It's thinner than a t-shirt. It's super, super thin. It's a fishing shirt. And see, it's got a hoodie. It's thinner than a t-shirt, and it's got a hoodie. And so I got it to protect my neck against the sun. It's SPF rated. When was the last time you bought a t-shirt that's SPF rated? All right, so the question is instant lock promise. Where does instant lock come from? I'd like to know what that is. If we can figure out what that is, or maybe I can just throw in the height. Because whatever the current height is, it's going to be the next height, right? I mean, that's my working theory. All right, kill all, VI. Let's see, okay. Okay. Instant lock promise. Wait for instant lock. Oh, look, they reinvented Go context. But I think this is actually something that JavaScript's trying to do. Yeah, Go found out that they needed this thing called context, basically to track asynchronous operations, and you pass context around so that you can cancel it and have the cancel bubble up, kind of like throwing an error, but different. What? Really? An hour? Oh, wait, no, that's 5 minutes? Wait, what is this? Because that's milliseconds. 6 minutes? You're gonna wait 6 minutes? You're gonna sit there and you're gonna wait 6 minutes. We got problems if you're expected to encounter the case of needing to wait 6 minutes. That's a poll problem, not a wait problem. But whatevs. Instant lock, asset lock transaction, output index. So my guess, let's see. I need to go look at some instant locks. We need that ZMQ thing that just shows what's going on right away. But let's go take a look at testnet real quick. No, you know what we need? Okay, we're gonna go over here. We're just gonna do get mempool, I think. Get mempool info. No, okay. Get mempool entry. Is there not a just get mempool? Mem. Get address. Entry. Get raw mempool. There we go. Really? Okay, but here we do have what this looks like. V size, fee, modified fee, priority time, height, descendant count, height. Okay, I think that's what we're looking for. So I think that we can fake the proof simply by getting the current height and incrementing by 1. Now, this may be slightly different from the perspective that there's different information that we get about the heights. Let's just see if there's anything in the mempool. No, nothing in the mempool. Okay. Instance send. Okay. So what we're looking for on here is basically instance send and height. So if instance send is true, then we can just take the height and use that height. So as long as we know what the current height is, we know what the next height's going to be, we can spoof these messages. So let's go ahead with that assumption that we don't need to actually do all the submit and all that. We can just go ahead and create the message, and if the message ends up not working, we just create it again, submit it again. Well, in this case, yeah, it doesn't. Shouldn't be that big of a deal. Because basically we're making a payment and we want proof of payment. And we're allowed to say, well, look in the mempool for the proof of payment. But we wouldn't want to go all the way incorrectly. It's okay if we take, like, basically, we spend the first money, we guess at what height it's going to be at, and our guess is going to be highly accurate. If our guess is wrong, we retry. And if our guess is right, then we didn't have to wait 6 minutes. We do need the asset lock proof because it is part of signing a transition. So you can see right here, create identity, create transition. We need an asset lock proof. Now, you may be right in that we might not need an asset lock proof. This may be the super common thing that we've seen in this code base where you're asked to provide excessive amounts of data that is an excessive, or rather, you're asked to provide data that is excessively high up, for which the information that's needed might be very small, but is excessively deeply nested within that object. So I wouldn't be surprised at all if we don't actually need an asset lock proof, but in order to work with these functions, we do need an asset lock proof. Because keep in mind, these functions are the ones that I copied over and I've been slowly modifying. They are not of my own make. But just for funsies, let's see if we can discern what is needed. Because probably what's needed is just the height. That's probably all that it needs. It's probably creating an asset lock proof for nothing, unless it's signed or something. Yeah, going back to gRPC. So you're like a decade behind, Ryan. You're so far behind. I can't wait until you get caught up, so we're not speaking 15 minutes apart from each other. Have I even been going 15 minutes? Okay, yeah, half an hour. Yes, Go is one of the ideal languages for gRPC because I think it was invented in Go. I'm not sure. I might be wrong on that. It is certainly used a lot in Go, and there are some people who prefer to use gRPC rather than the web because they're using it for internal services where they have a variety of servers that they never go out to the web. They just talk to each other. And I know that it is used for that. But there was an excellent talk that I don't remember the name of, and I don't know whether it's on Creeds of Craftsmanship or not. But the guy was talking about how they just did everything in JSON and it worked out fine. that, you know, people were saying, oh, well, you know, JSON's too big, you know, your byte size is going to be twice as big as you need it to be, and yada, yada, yada. And then it turned out that using JSON made it super easy to debug. It made it easy for everybody to work with. So they're able to build a product very quickly. And they never actually saw the hypothetical network slowdown that was being talked about. And I mean, ultimately, I want to skip gRPC entirely. I want to figure out what the DAPI stuff is and just go direct DAPI. There's no, from the technical perspective, I don't think there's any reason that we need gRPC. Obviously, yeah, to get the prototype out and whatever, yes. But I don't think that any of the gRPC is actually necessary. I think that it's one of those abstraction layers that they just threw on there because abstraction is so cool. And there's so many different cool technologies you can work with when you abstract all the things, don't you know? Just building up resumes, baby. Think of all the tech you can work with. Okay, asset lock proof. Weird. Why bother doing it in TypeScript if you're not going to use types? All right, do we see this? Oh, you got to be kidding me. So you call identity.create, which calls create. Oh no, then you call create identifier to create identity create. Blah. Yeah, so asset lock proof, who knows why? Oh, no. This is create identifier. This would have been better named create ID, or rather get ID, or hash ID, or calc ID. This is asking for the ID of the asset lock proof, which might be just the TXID. Which TXID? Yeah, I'm guessing that this is actually a TXID. It's just a standard TXID. That's my guess. But yeah, you know, it is that thing exactly what I said. You can see here, this is being passed down again, yet another layer. So if we wanted to figure out where that came from, we'd have to go find it in that layer, and then in that layer, we might, you know, ideally what you do is at the top layer, you'd get the minimal amount of information that you need, unless it's something that's really, really tightly coupled to the specific implementation, which this is not, because I am dollars to donuts. This is a TXID right here. Now, whether it's forwards or backwards, we can figure that out once we log it out, because we already know how to create TXIDs. But, you know, you're passing in an asset lock proof, and you need this one piece of information that's not really super integrated. You know, it's just a normal piece of information. You just pass in TXID. You don't even need an asset lock proof object for that. You just get that off the transaction object. But that's what I'm thinking that this is. I'm thinking that it's associating this identity with this asset lock proof, and it's doing it by the TXID. Anyway, I'm going to go look at create identity, create transition real quick. But first, I want to figure out where DPP is coming from. Okay, so this is platform. That's DPP from platform. Okay, so this is not the same thing. Where's DPP.identity? Oh no, we're going to have to trace that down. That's okay. So now we got half the code is in WASM, half the code is in this other place, whatever. We'll figure it out. That's going to be a little bit more annoying than I would have liked, because that DPP is not the same as this DPP. They are different DPPs. So that is a little bit of a pain in the butt. So my guess, okay, let me just use my reasoning skills here from what I've seen in the code base. Create identity, create transition. What? Oh, this is so frustrating. So we're passing in identity, and then we're passing in asset lock proof again. We have some thoughts on what that asset lock proof might mean. You know, what it might be using it for. The identity, I guess it'd probably be using it for the keys. I think the identity is just an abstraction around an array of keys. Oh, so identity create transition. So this is saying it's a transition. And then we're going to sign it, but then we're going to use identity master public key, which is what was passed in up here. So it looks like we just have a lot of circular references. We just have a lot of places where something's passed into something else, and then it uses that thing to pass it back to itself, to use that thing to pass it down to the other thing, pass it around, pass it around, pass it around. It's like playing hot potato with identity, lock proof, and transition. Because they're all calling each other. We don't have a directed graph of this calls that, this calls that. This is a parent, this is a child. This is a loop-de-loop here. Yeah, and then you see that here with the, you get public keys, but we already had the public keys up here. So it's particularly ironic that we're calling a method to get the public keys when we just had them. But whatever. Okay, so create identity, create transition. Let's look up that. And I'm hoping we can find out. It would seem that this is probably just going to call a method on identity and then access a property on asset lock proof. If we could just replicate that functionality, that would be ideal. Yeah, because we're just, yeah, see, look, here's those keys again. So we had the keys right here, and then we're getting the keys again down here. I guess technically the difference is that these are now, well, they could be a derivation. I don't know how the system works, so it could be derived. So it may actually be doing unique logic there. Okay. The instant lock it's waiting for is just the main L1TX lock. Yes, that is correct. For the POC, we could either assume it's locked after 3 seconds or do the work if WASM DPP doesn't do it. No, WASM DPP can't do it because it's down in Rust. So it's not going to have access to things like a network request. That's okay. We can do the network request. What I'm saying is we don't need to do the network request because we know what the height's going to be. You know, it's not this indeterminate state. There is, you know, the possibility where you submit it right on the edge, and like there is a case where you could just have to submit it a second time. But you'd be better off just submitting it a second time because it'll be way faster to take a guess, send it out to the network, and then get a rejection than it would be to wait, then send it out to the network once you know, and then have it accepted. So instead, guess, send it out to the network. The network is either going to accept it or reject it. If the network rejects it, then guess again, and then send it out again. And if it wasn't the one, it will be the other. And if that fails twice, then there's probably something else wrong, but there is a slight chance that there's a fluke in the universe and you have to actually wait 6 minutes, but I doubt it. Asset lock TXs need either a chain lock and an instant lock, as I recall from our convo. Right. But he does, so I don't think he knows. I don't think he knows because he hasn't dug that deep in the code. So yes, that is what the code tells us. But the code is telling us way up in one of these layers, way up here. But that's not telling us why. What is it about a TX lock that's so special? What is it wrapping? What information is it wrapping that something else wants? Let's see. I think, no, it's not there. Is this it? Okay. Were we not just here? It gets kind of confusing, doesn't it? Create identity, create transition. We were just there. No, okay. So we have two functions named create identity, create transition. We have one. What? This can't be right. That looks cyclic. That looks as though it's using itself where it's defining itself, and that doesn't make sense. I'm going to assume that that's wrong. I'm going to continue looking. Because this is platform, this is method, this is identities, this is internal, this is create identity transaction. But this doesn't make any sense because it can't call create identity transaction from create identity transaction if it is the same thing, right? Wait, what were we looking for just a second ago? Create identity, create transition. Okay, so create identity, create transition. And create identity, create transition is this function here. This is very confusing to me. This is probably the most confusing thing I've seen recently, because we can't be calling the function from itself when, like, that doesn't make sense. Let's just double check here. Does this function signature match the other one? And they could still match. Is it identity? No, this one does not take in identity. This one takes in platform. So there's another function called create identity, create transition that's defined somewhere else. So there's two functions that belong to different objects. Both of the functions are called create identity, create transition. That's what I'm getting. Create identity, create transition. So we would need to find out where. So there's this thing that initializes. So platform is this. So it's saying this is platform. And then it's initializing it, whatever that means. And then it's getting an account wallet. And then it's getting DPP from platform, which is itself. And then it's calling dpp.identity. But it has a different method signature. See, this one has asset lock proof and asset lock private key. We have an asset lock private key. And I think we know what an asset lock proof is. I think that it is the height. I think that's the only unique piece of information about an asset lock proof. Oh, no, it's the height, it's the TXID, and it's the output. It's those three pieces of information, if I've got that right. So we just need to figure out where is this function defined so that we can basically copy over a few lines, hopefully. I don't know. We'll see. All right. So there's utils. This has utils, and that's definitely not. This is the spec. Let's see where it's drawing this from. There may be another package. That happens sometimes. There may be another package that this stuff is created in. In fact, let's go search the GitHub repository or the GitHub organization, because it may not be where we think it is. It might be somewhere else, because that has happened before. And that doesn't feel good. I don't like it. But let's see how many places this pops up. It might pop up in Rust. It might pop up in a couple of JavaScript libraries. It might pop up in WASM. All right. So, what is this? Kotlin? We have it in Kotlin? Okay, that might actually be worth looking into. Yeah, if we can have a better, like a language that the people who wrote this in don't absolutely abhor and hate with all the passion of their souls, we might be able to find some better code, because it turns out sometimes, not always, sometimes when people are writing in a language they like, it's easier to follow what they're doing. So we can try it out in Kotlin. This identities. Okay, bindgen, create identity, create transaction. This is so confusing. So there might be, there might be something else. There may be another object being exported out of WASM, and this would make sense as to why we didn't see in the JavaScript code. So the thisness may be something that inherits. So that instance of platform may not be the JavaScript instance of platform. It could be that it's attaching a JavaScript function on the WASM instance of platform. I'm not really sure how that works. But I will say that the Kotlin looks interesting. I want to take a look at that. So this is Kotlin. This is certainly, it looks like it's easier to read already. Okay. Wait, Bitcoin? Oh, no. All right, so that's a rabbit hole. We have to go then find this Bitcoin project. I don't want to do that. Okay, well this is more helpful. Okay, create transition. This is looking more helpful. Can we find where this is defined? Hopefully this is in this organization and not a Bitcoin organization. I have no idea why it would be in a Bitcoin organization, but maybe I heard talk about transition not being a dash thing, but being another thing. Now, none of these particularly look like declarations to me. Let's see if we can find out where this comes from. Okay. I don't see it imported anywhere here. So it may actually be defined in this file. It must be imported from somewhere. I don't see where it's imported. Okay, here's something that looks potentially useful. This is a set of fixtures. Fixtures usually have actual data in them. Okay, identity. So let's see if the folder structure matches. Okay, can we go from DPP to identity? Oh, no, not identifier, identity. And can we go there? Identity. Oh, that's weird. This has a test file. Does it have... That's... I don't know what to make of that. Are we in the test files? We're not in the test files. Well, that's very confusing to me. Because these are test files. This is not real code. Spec, 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 test, mock. So this is not real code. So where is the real code? Because when we look at the path, it looks like it would be platform, DPP, identity. So let's look at the path we're at. -J, platform DPP, identity. How can it be that these files are, there's no code in here? That's all just test stuff. How can that be? Because look, it's declared there. I mean, and that's not declared as a test file. That's declared as an actual thing. Okay, well, we've got a clue here. Raw straight state transition. That's probably bytes. Params. That's not very helpful, unfortunately. All right, I don't want to bark down this tree too long, but you know, this is the average story. You know, you go and then the code's not there. So where is the code? Let's see. These are all... Oh, sorry. I didn't see that we were in the test files. Because I'm looking back. I didn't see anything about test. We're all the way back here. Okay. So now if we go back here, and then we go to main, then we go in here, then we go in identity, then we go in identity create transition. Okay, this is where the real code is. All right, params is network parameters. Which... maybe, can we find where network parameters is defined? Network parameters is probably under a different organization. Let's see. Let's go back up to main. Genilibs? Nope. Or whatever that means. Resources? No, I don't think so. Although schema would be interesting. All right. So let's try going to a different repository. Nope. I don't know. Yeah, I don't want to have to chase this down through Bitcoin and all that, but they may have just named the dash repository Bitcoin because that's what they like to do. Because they really love Bitcoin. So it may be that in here... Oh, baby. That's what it is. They call dash Bitcoin. All right. So now we're getting to code that we might be able to read. All right. So core network parameters. Are we in core? Core. Network parameters. Oh, interesting. I wonder what that means. Oh, deprecated. So maybe we don't need to worry about it. Okay, so my guess, from looking at this, my very hopeful guess, is that network parameters is basically not really doing anything more than passing the string main or test. I think that's what network parameters is doing. And maybe a few of the magic... let's see, do we have any hexadecimal in here? No, we don't really. Oh, we've got some hex decode. Do we have any of the 4C or the 80? All right. Okay, cool. So this is about what I expected and was hoping. Is it looks like probably the only thing that's used for is this right here. Let's see what's not protected, but what's public. Minimum confirmations, spork address. What else is public in here? Target time span, target spacing. Max coins, max money, get ID. I don't know what that would return. It's probably the network ID. It's probably main or test. Let me see if I can find that again. The string returned by get ID. Oh, this is the Java ID. So it's not the network ID, it's the Java ID for the network. All right, similar. All right, public get ID. Okay. Okay. From ID. All right. And then we go over to mainnet params. I think what we're going to see here. All right, it's going to call super, which I believe is the network params. And this is where it sets the magic bytes. Okay, cool. All right, now I understand what that is, so we probably don't really need that. That's good. This is good. I learned something. It's very good. All right, so params is probably not really important. It's just probably used for encoding. You know, how do we want to encode the address? How do we want to... I mean, it's critically important, but it's trivial. Okay, raw state transition. And is this in this repository or is this in a different repository? This was one we were looking up earlier. Okay. All right, so I lost where this was coming from. DPP identity, was I not looking here? Okay, here. This is where I'm looking. So that's where the network parameters are. Okay, asset lock proof, public keys, protocol version. So let's take a look at asset lock proof. That's one that's really interesting. If we could figure out where that comes from, that would be really great. I'm going to pull this out into its own thing so I can explore a little bit better. Asset lock proof. There we go. Oh no. Abstract class. Get out point. Okay, we know what those are. And get identifier. Boom. That's it. So it's the height, it's the output index, and it's the TXID. That is what asset lock proof is. I mean, I can't prove that with certainty, because I don't know what this actually means. Abstract val type int. I don't know what that means. Type might refer to something else, but you know, it's even if I have to, you know, go look up a little bit further. I'm going to make some notes on this. This is actually good. This is actually good stuff. All right, so let's bring that over. Bring this over. So this one was, what were we finding in here? Identity create transition. Asset lock proof. Okay. That type, I wonder what that refers to. Abstract val type. I think type is the name. Kind of weird. All right, whatever. All right, so we're getting closer. I feel pretty comfortable about public keys, so I know what that is. Protocol version, not 100% sure what that is, but I don't know that it really matters either. I know that we have protocol version somewhere. Like if we do, let's go back and do the RPC thing real quick. So if we do get blockchain info, one of the things that's going to fetch, oh wait, it doesn't like that. Hold on. It's because I had the previous parameters there. All right. I believe that this has version in it somewhere. Soft forks, warnings. No protocol version. Oh, interesting. I've been wondering about this one. I wonder what height we're at. Hold on, let me check something out. Okay, so this is the block we're at. No idea what that means. I wonder what would happen if we did the mod of that by the super block. I think that might be how we get the budget. Because, you know, it does seem like it says that. All right, so it seems like there's a way of serializing. It's probably doing the variant stuff for serializing. My guess is that this to buffer. I could be wrong because there is something else in there that we're not really seeing. Whoops, if I can get this to move over here. So my guess is the instant lock to buffer is actually serializing the TXID, the height, and the V out. But it would be nice to know what that type refers to. That'd be something that if I can figure that out in the next couple of minutes, that would be great. And then protocol version, we can find it somewhere. I don't know where. I know I've got it in some of the code I've written already. I think it's in the -gov code. But I don't know where. I don't know if there's a canonical place that you get this from, or if it's supposed to refer to the code rather than the network. I guess it probably should refer to the version of the code, not the version of the network, so the network knows whether or not, like, how to expect to parse it, because the way it's parsed could be changed in the future. Okay, so anyway, base object, maybe this abstract thing has to do with that, but I'd be kind of surprised if, okay, all right, wait. Okay, let's turn this around. Let's turn it around. Maybe the reason that it wanted the height was that it was going to get the TXID. Maybe I had it reversed. Maybe it's not getting maybe it's not using height at all. That makes more sense to me. I don't know why it would use height. It just, we saw in the code, we saw for certain, without a doubt, that it was using height. But it makes more sense to me that height is not actually used. So let's go back to this. Let's see if I can go back a few. Whoops. Okay. Asset lock metadata, height. Create chain asset lock proof. So it seems a little weird that we would pass in height here. That's what threw me off, because you would think if you're passing in height, well, why are you passing in height? You're passing in height because you're going to use height. I think what it's actually doing is it's going to use the TXID, and it's using the height to get the TXID. That doesn't quite make sense to me. But it seems to make more sense than the height being a native property of the asset lock proof. I think that this is just a lot of ceremony to be really, really roundabout about saying the normal thing that you always want for an output. TXID, output index. But then if that were the case, then you would just need the asset lock transaction and you wouldn't need instance send. So maybe it is using the height. Hard to say. Because this could be an optimization before it gets indexed by the database or something. Find it at this height specifically, because it may be much faster to find it by height. I can only guess at this point. Okay, but let's do. I want to dig just a little tiny bit deeper on the asset proof here. I want to see where it's instantiated, if I can, or where it's used. Interesting that I don't think that it didn't define a create identifier. Oh yeah, it did. Okay. Create identifier, it's just TXID. Okay, big Indian. What? Followed by the output index in little Indian. So I think that's what to buffer means here. Oh, so this main, oh no, this is TXID. Oh, this is Diffner. Okay, so this is a different type of thing than I've seen before. Okay, let me read this comment. The identifier is the double SHA hash of the out point structure. That's the to buffer, which is the TXID in big Indian. So normal order, considering that big Indian doesn't even make sense for TXID because TXID is a byte stream, and a byte stream is just the sequence of the bytes. So the fact that there are places in the code where it's in little Indian doesn't make sense, because you don't little Indian a byte stream. A byte stream, like, I don't quite know how to articulate it, but a byte stream doesn't have Indianness. It's not until you try to decode it into something that does have Indian. Indianness would be something that can be operated on by a CPU. A hash cannot be operated on by a CPU as an instruction. Well, I shouldn't say that. There may be such a CPU that exists. I don't know of it. There might be one of those Bitcoin miner style ones, but all the same. Whatever. Okay, TXID in big Indian followed by the output index in little Indian. So this is gold. First piece of documentation we found. Excellent. Okay. Cool. This is great. We're making progress. So what's really strange, though, is there's all this extra information. But then again, that's the pattern that we've seen, right? Like lots of extra information, lots of extra code, blah, blah, blah. What's up, Black Mirror? You know, so that is, you know, really, when you think about it, it seems strange, but it's par for the course with the way the, you know, the code has been up to this point. You know, we need 2 pieces of information to get there. We've got 6 classes, 7 layers of hierarchy, and, you know, a multitude of red herrings. But I think that's right. Now, it would be really cool if we could find where this is instantiated. But as you can see, almost everything here... Oh, wait. Here's one. Proof. Yeah, I don't know why this type gets passed in. As far as I can tell, it's not used anywhere. And this is the only place where I can find it instantiated. So there's only 17 references. And maybe it's because it's an abstract class or whatever. Maybe it doesn't get instantiated directly. Okay, type equals 1. Says who and why. I don't understand what type means here. We just have magic 1 and magic 0, and that's the only ones we've seen so far. And they could just be chosen at random, because we've seen that in the past, you know, 1, 2, 3, 4, 5, 6, 7, 8. Okay, let me move this over. I'm just going to open up each of these and just see if I can glean any information. I just want to make sure the type's not used. I'm pretty sure the type is not used. Everything that we've seen so far and reason itself seems to indicate that it's just a hash that's created from the TXID. All right, we're not seeing anything there. Okay, close it out. All right, how about here? It's not even in here. Why did this file come up? Oh, whoops. Let me look in this one. I did the wrong thing. Okay, look at this. Look at this. Chain core locked height. Okay, so good. I'm glad to see it. I just don't know what to make of it. But we do have a constructor there. All right, let's see what we can learn about height from here. Okay, so it looks like when it's turned into JSON, and these are the same, so you know, whichever one we. All right, so I think that we actually don't even need the height at all. We don't need the instant send or, yeah. So only for our own purposes of verification, in debugging why it fails, would we need to know the height. So if it fails, then we need to know the height. Hey, thanks, Black Mirror. Thanks for liking my setup. I like that you like my setup. Double liked. All right. Yeah, I don't think this is used anywhere else. I think that's it. I think that it's just debug output. No, it is not a Sony Alpha camera. I'm old school. This is a Canon T8i. Unfortunately, the worst camera to have invested in the sense that there will never be another camera in that series. And so all the lenses and batteries and everything that I have for it will stay with it because there's nothing else. They switched over to, I think, they switched over to mirrorless. The same grade of amateur camera is now mirrorless only. And of course, because, you know, money, they changed the fitting on the lenses so that for no particular reason, you just have to buy new lenses for everything. Because otherwise you'd be able to use your grandfather's lens, you know? I don't know. Maybe there really is some sort of a reason. Maybe because it's mirrorless and it decreases the depth of the camera, maybe they actually do need a different lens because when you flatten the camera like that and bring the lens closer to the sensor, I could see potentially a real reason for changing the lenses. Yeah. But it's not that big of a deal. I'm not into it very deep. I think I have 2 or 3 lenses for it. I really only use this one. I kind of settled on it. Occasionally I use the other ones for something fun, not streaming, but just like taking pictures of butterflies or something. My grandpa didn't have OBS, so probably those lenses are a bit less okay. Yeah. Yeah. Anyway. All right, so we're done with this one. I'm glad to see that there. I'm glad to see that it is only ever used as a debug value. That seems kind of silly. All right. We're not seeing it in here. Assert, or no, asset lock proof. Okay, let me get out of there. I'm gonna go through these pretty quickly. All right. Yeah, I see that. So I think type means nothing. So I'm just going to look for that and height in each of these just to make sure that there's no new information. Yeah, let's just debug, debug, debug. See, here we have type, but we don't have height. We have params that's basically just the network stuff that's not particularly important. It seems that it has what transaction it's part of, what's instant lock. I don't know what instant lock would mean here in this scenario, but maybe it's the ID of the block that it will be part of. Instant asset, yeah. Okay, I'm feeling fairly comfortable. There's a lot of steps here, and each step builds on the next step, so it's kind of important that we not mess it up if we can avoid it, if we can be a little bit careful about this. But we've got 5 or 10 tabs left maybe. And it's going to be pretty quick through all of these. I'm just looking for any outlier information that doesn't match my expectation. Again, we have this create instant lock. Okay, this is confusing. So we got the same thing in Kotlin where we have this kind of recursive or self-referential create instant asset lock proof, but doesn't seem to really do anything. It just has some methods on it or something, but what would we do with them? That's where it's really confusing. It's just the whole thing's really confusing. All of it's really confusing. Okay. Dash SDK, Android DPP, debugging code. Can I have a bit of context? I'm more into design rather than code. For me, it looks like science fiction spaceship manual. All right. That's kind of what it is. You kind of hit it right on the head. So the Quantum Explorer has created a new blockchain network. And I am commissioned to create a demo using that network. And I think that the username Quantum Explorer has a lot more significance to it than I could have originally anticipated. Okay, that's all. So what I'm trying to do, it's difficult to explain. I can't really, I don't know, so I can't explain it because I myself have not learned it yet. 2, what I do know doesn't make any sense to say out loud in words. So what I can tell you is I'm going to create a private key, a set of private keys that are considered to be an identity. And I'm going to take a public key that represents the private keys, the multiple private keys. I'm going to publish that to a blockchain. And I'm going to do a number of transactions on an L1 blockchain and an L2 blockchain that will turn that public identifier into a registered entity on the L2 blockchain based on information from the L1 blockchain. And then I'm going to be able, at some point in the future, to be able to create a username. That is the most friendly synopsis I can give. But on my other channel, I often do things that are a little bit more relatable. Gotcha. Sounds like a solid plan. Indeed. Indeed. Yeah. But in case you can't tell, I'm a little bit frustrated by this. Well, I'm pretty much always frustrated. I'm always frustrated by it because I think that they're not thinking about other people when they're doing this. They're trying to, I think they're trying to come, so basically, there's that triangle and it appears everywhere. I'm sure that you've got something in your industry of design. There's the triangle. And the common one is fast, cheap, and good. You can pick two. And it's a law of the universe. You get to pick two. You don't get to pick three. But sometimes if you squint at it just right and you kind of twist it and you kind of fold it back over on itself and then you clamp it and then you put it into an interdimensional wormhole, it kind of looks like you can get all three at the same time. But you can't because you did all that twisting and clamping and wormholing. So you didn't get all three. And I think that that's a lot of what's going on here is there's some chasing of perfection when perfection is not an attainable goal. You have to pick a trade-off, or in many cases you can actually pick multiple trade-offs. You can say, we're going to allow you to ride the bus or drive your car. You can do either one. So we've pared it down to the best possible set of trade-offs. And you can do either one. You can take the bus and it won't be fast and it won't be cheap, but it'll be kind of cheap relative to maybe car. It'll be comparable compared to like paying car insurance and gas and all the other stuff. But you'll get your time to do what you want while the bus transports you. Or you can take your car and it's faster and it's about the same in terms of price, but you can't have your time to do something else because you have to drive during that time, right? So we can give you both options. We did not create a solution that is, allows you to have your time and is fast, but we can say, if you want to take the bus, you can take the bus, but then tomorrow you can still take your car if you want to. And that's kind of how you achieve perfection. Is not by trying to come up with a single solution that does everything, but by coming up with a set of solutions that the set of solutions are compatible and don't compete against each other. They supplement each other, not compete against each other. And then that's workable, right? So that is literally the best you can do. You can't come up with one solution that has no trade-offs. But I think that a lot of this, it gets really, really complex because it's like, well, we can't just take the hash, but if we take the hash of the hash and we add a nonce and we hash that, and then we submit that to the one network, but then we go grab it from the other network, but then we pull that and then we use a hash of that, and then we hash that, and then we put it with the key from the other network, and then post the key, and then get back the key, And at some point, I don't know what it's trying to achieve. I haven't gotten that far yet, but I get the sense that that it would have been better to just say, okay, well, you can do this, and you can do this. And sometimes this is going to be best, and you'll know when that's best, and you'll ride the bus when that's best. And sometimes driving the car will be best, and you'll know when driving the car is best, so you'll choose to drive the car. But I think that they tried to make a bus car something other. I think that's essentially what's going on. So anyway, I'm going to check this one more time. I think I already looked at these. Okay, we'll get out of that one. Okay, this one, there's nothing in there. This one, there's nothing in there. This one, there's nothing in there. This one, it doesn't look like there's anything in here. Nope, nothing's in here. This is just abstract imports, whatever. Okay. All right, so this one I think we already looked at. Constructor, asset. Okay, this is actually one I think we have to come back around to, but we probably don't need to worry about it right now. All right, object JSON identity ID. Oh, this tells us identity ID, which may in fact be useful. Also, okay, here's where this may come into play later on, is that it may be that as part of passing the object around, that something else needs to access the height of the blockchain, the most recent, or the block height, meaning the block at which this was submitted. That may be where that's useful. Okay, but I don't think we need this. Okay, so I'm going to close it out. Again, I don't want to spend all day going through here. I just want to see if there's anything that challenges my assumptions and all the places that I can find this referenced. And then I'll go read some more comments, and then I'll keep getting at it. Okay, so this looks fine. Identity public key, that's just the index. Okay, that stuff, create identifier. We already know what create identifier is, I think, if I don't forget. And I did make a note on it so that I hopefully won't have to worry about forgetting. Okay, so that one we can close out. Okay, again, we have this type, but we have no documentation on what type means. So in all the files that mention type, there's not been so much as a comment, an enum, anything to identify what type is, which I really would like to know what type is, but it seems like it may not be important. It might be something that was added early on and just, you know, never got deleted because whatever reason. Okay, that looks good. All right, we're at the home stretch here. Okay, and then we have the different types of proofs. So an asset lock proof will either be a chain proof or an instant send proof. So either it's committed to a block already, or it is confirmed by consensus that it will be committed to a block shortly. So yeah, we're good. We're good. I think we don't need to do any of that waiting. Because assuming that you construct it correctly and assuming you broadcast, let's say that you broadcast it late, okay? Let's say that you actually broadcast it late and it's not confirmed yet. I wonder what's the worst that could happen. Let's say that I create my identity a week before I actually successfully broadcast my collateral, not collateral, what do they call it? My identity payment. Well, if I go to look up the identity stuff at any given time, it's going to reference that ID. And so whenever it's referenced by that ID, and it looks up the ID by the index, whether it happened the same day or a week before or a month later, I don't think it should matter. Not that I think that should be, you know, not that we should, you know, store it and wait a month, but the ID doesn't change based on what block height it's submitted at. And I've already tested this with some other stuff. So, okay. All right. Now we're back down to the core stuff. All right. Let me catch up on some comments. I did the design for Platform Explorer and kind of have the picture in my head. Fast, cheap, and good. I pick Pikachu. Nice. This is why I take my longboard. Giving options. I don't know. Bus car racer. Yeah. Okay. Yeah, I haven't really looked at Platform Explorer. Well, I have looked at it just a little bit. Okay, so now we need to move on to the next thing. So, the good news is we've pretty much confirmed that we don't need a special type of constructor for asset lock proof, except that I still don't know what create identity, create transaction is. So maybe if we go back and look at this now, I'll be able to understand what it is, because now I know what an asset lock proof is. Or at least I know the possible components of an asset lock proof. All right, did we have this one over here? All right. Okay, so look, this is a WASM identity. That's good to know. And the asset lock proof is a JS value. Okay, this is actually really important because we need to know what Rust needs to know about this asset lock proof. So what would be really good to find is this function right here, which I believe we can find, because that function should tell us how to construct a JavaScript object without all the hoopla. Wow, that is way more references than I was expecting. Okay. These mod files are normally empty. Let's see if we can find another place. It looks like it's declared in the mod file. Let's hope that it's not empty. All right. And then what were we looking for specifically? We're looking for create asset lock proof in WASM instance. Okay. All right. So, all right. New none into from string get type. Oh no. So it's using type here. Ah, crap. Okay, so we're gonna have to, dang it. We will end up, because this depends very heavily on the specific, well, I don't know. I can't read this. I have a vague sense of what it's doing, but it's okay. So let's just JS sys reflect get JS value. So I'm not sure whether this is a receiver. This is Rust, so that shouldn't be a receiver. Where's JS value come from? JS value is essentially, it is the object with all its prototypes and everything. So JS value and another JS value, what? From string get type? I don't know what this means. Get type. Get type. Get type value, get type. Reflect, get type. So I don't know if get type is supposed to be a thing that's on an asset lock proof, but we can't just pass in the values that we need. This is at some layer, and this is confusing because I don't know at which layer this is happening, because again, we've got several functions that have the same names, but they're in different layers of abstraction. So somebody who knew WASM and Rust, maybe GPT can explain this. I'm going to ask GPT. This might be a stretch because the number of people using Rust, not that many. Number of people using WASM, not that many. But let's go ahead. Let's paste it into GPT and let's see if it can tell me what I need to pass a JavaScript object into this Rust WASM function give me an example of what this object looks like. This is going to be a stretch, but we'll see what happens. Oh, hey, look at that. This is actually doing pretty good. Okay, so getType is a method. I don't know how it would know it was a method. The name sounds like it'd be a method. And again, it's doing statistical analysis. This may be bogus crap, but... What? What? How did it know that? Was that in the code? I mean, I just went through all that. I never saw a type 1, or no, I never saw a type 2. I only saw type 0 and type 1. Ah, I think it's guessing. It's guessing. It doesn't know. It might... So 0 might be instant. Okay, so this is where it comes in to... Okay, so, all right. So again, it's highly dependent on the specific implementation of this is a poor mix. What we would want to do is we want to pass in a very clean value object. If you're going to go across a boundary like WASM, you want to pass in a clean object that you really want to be passing value objects across boundaries. You really, generally speaking, don't want to be passing complex hierarchical objects across context boundaries. But okay. So GPT is guessing on what instant and chain are. We can figure out what they are, though. My guess is that instant is 0 and chain is 1. And the GPT did an all right job of guessing on that. So I'm just going to try to find in here. I'm going to try to find chain equals 1. Asset lock proof. That's what I expected. Okay, so now we know what types mean. There we go. All right, we're getting closer. We're getting closer. So, okay. Type does matter, but maybe only to WASM, not to the eventual thing we need to get from it. Yeah, this is going to be very, very fragile WASM. Okay, so let's continue. So it is helpful. All right, cool. That was helpful. I'm surprised that that was genuinely helpful. All right, checking on comments again. Focus on the solid plan. Curious to see how it works out. Ask GPT, my favorite part of the show. Need to run. Have an awesome stream. We'll watch on replay. All right. Have a good one. Adios. And I don't know if the comments have been popping up here. It looks like recently we've been having this problem with the chat not loading properly. And I have to go in and add a cache bus to it. Okay. Woo! Alright, my eyes are burning. Did you check the dips or reference docs? You know, if one, point me to it. The asset lock was not in any of the dips. But if you look at this, are you still far behind? Are you doing that thing where you like go watch something else for half an hour and then watch this on 2x? Just look at this line right here. The type is being used for some sort of, it's like I said, it's an instance of cheat. So instead of doing further reflection on the JavaScript object to figure out what its inheritance hierarchy is, it's getting the type so it can then do a Rust enum. Now, where it needs to use this later, I don't know. And that's, yeah, this is a real pain in the butt. It's a real pain in the butt because what's the point of having the WASM library? What's the point of having the WASM library if you're going to so tightly intercouple the two that the WASM library can't take, straight values? And you just can't use it in a reasonable way. So this now has a hard dependency on extremely implementation specific types. That's a pity. But, and it's even weirder because of the way this is going to work. Okay. So create identifier. Again, this is not something that we need to worry about. This is so weird. Because it's going to create the identifier the same way. Now, this is what's funny about this, is the identifier is the same either way. The identifier, as far as we've looked up so far, the identifier is the TXID with the output index. That's the identifier. So even the very idea of having to do this all over the place. So see now, look. So instead of unwrapping it, they're just putting all this duplicate logic everywhere of, well, is it the chain one or is it the other one? Is it chain one or is it the other? But they have the same data. All right. I'm gonna take a moonshot here. Is this test stuff? This is all test stuff. This is down in the test section. All right, so this is up in the. I'm gonna do a little moonshot here. I'll click on your dip. All right, let's see. This one? What do you want me to see here? Yeah, I think this is one that I've already looked over. And yes, it's very possible that I missed a sentence. But this is all English. It's not helpful. It's not telling me byte orders. Oh, wait. Oh, no, that's the one we already have. Yeah, I don't think this is okay, sign height. Okay, wait. Okay. Unlock transaction. All right, no, that's not. So that's unlocking, not locking. Locking. Yeah, okay, that makes sense. Unlocking. We're not worried about unlocking yet. Yeah, if there's something specific you wanted me to look at, fine, but I'm pretty sure this is the one that I've already been through. Especially considering that I've already done this. So, all right. Yeah, so it has no idea. GPT has no idea. It cannot tell. It cannot tell what that's supposed to look like. It got no further information. Lock type, match lock type from WASM instance. Yeah, it just lock proof instance. But the only thing it looks like it's doing in here, if I understand this correctly, is that this looks like it looks like it's just doing create identifier. And we already know what create identifier is. So assuming that this create identifier is the same as the Kotlin create identifier, which may be not the correct assumption, this is just absolute silliness. Because it already knows how to create that identifier in JavaScript. So why would you be up in JavaScript, call out to WASM with a highly implementation specific hierarchical structure to have it import that structure to create a method that it already has? Again, like I don't empathize with the people who wrote this. That's who I don't empathize with. And it just makes me angry. It just makes me angry. Yeah, the asset lock stuff is still, I mean, even what you saw there, if you saw it. No, it's whatever. Okay, let's go back to this. So I'm going to take a step all the way back here. Now I've got a lot more context. Create identity, create transition. I still don't really have any idea what that means. But what I do know is I know how to get the public keys. I'm pretty sure. I think they're normal public keys. I don't think that these public keys are special public keys. Now, I will go check, but I don't think they're special. So what we need to know is, what does create transition look like? That's one where I think I'm still a little bit lost because I went down the asset proof rabbit hole. So let's get out of the asset proof rabbit hole and let's get all the way back up here. And let's look at the Kotlin. Oh wait, no, we don't want to look at that. That's this one. You've got to be kidding me. Ugh, we're back to this. The Kotlin is easier to navigate, but it's a little disappointing. Rather than just calling the constructor, there's a create function that wraps the constructor. Whatever. Moving on. We're making progress. This code base at least is searchable, and there is code at the end of the rabbit hole. And it's code in the same language. We're not going back and forth between Rust and JavaScript, or Rust and Kotlin, or Kotlin and JavaScript. So this is fundamentally, we're going down a path that seems productive. Oh, there's a fixture. I wonder if the fixture is just 1, 2, 3, 4, or maybe it'll have real values in it. That would be really nice. Look at that. That looks like a real value. That looks like, that's not 1, 2, 3, 4. Okay, some of this might be... Where did it come up with data contract? Oh, this might be one of the real objects. But what was I looking for in here? I was looking for identity create transition, right? Is that what I was looking for in here? Protocol version, type, asset lock proof, public keys. Okay, so here, identity create value is referenced. Oh, so it's the number 2. Okay, so I do want to look at this one. All right, so class type, state transition. So the transition state type, identity create, this is good to know. Okay. Okay, last link, and then I'll shut up. So you say. Like, I get your frustration that sometimes, further down the page, there's information that would have helped me, and I'm too quick to skip past it. But at the same time, I can't read every document from beginning to end, so I have to skim for information that looks relevant. And if I'm not finding information that looks relevant, I'm going to move on. Because there are too many documents. If it was like, okay, here's 10 documents. If I read these 10 documents, and the documents were, say, a page long, then it might be worth it to listen to it like an audiobook, and then do some work, read it carefully, and listen to it as an audiobook again to like really get it in. But we're talking about hundreds of pages of documentation on a dozen different websites, and 40%-ish of the information is meh at best. All right. Current reference implementation is RSDPP. Identities, create, data contracts, state transitions, type, identity, create. This does look promising. Like, if this is what I'm supposed to send, like, I'm just supposed to construct this object. This looks very promising. Now, I don't know what to do with that. I guess I'd have to send it over gRPC or something. But if this is what we're looking at, this is good. Oh, okay. Example state transition. Okay, this right here, Ryan, this is gold. Question is, where do we find protocol version? Now we know what type is. Why the letter L? Why would you do this? Why would you do this? Why would you make this a number instead of making it the string identity create? Like, you're going to have these signatures that are 6 million years long, and you can't be bothered to put new ID as the type, you know, if you want to shorten it from create identity, you know, whatever. Okay, but this right here is potentially gold. What would be also helpful is if we could figure out what this means, because here, and maybe we can get some of what it means from up above. Okay, 2 for identity create, protocol version is 1, asset proof object. Okay, I would like to see what type 1 looks like. This is base 64 encoded, so let's base 64 decode this, because this very well may just be JSON. Oh, I found the place where this, not this type. I found the place where this type is documented, and I found the place where this type is documented. So those two, I found that in the Kotlin code. But it would be helpful to understand, because this is defying my expectation a little bit, because this, what I was expecting, and maybe that's what this is. Maybe if we took this from base 64 to hex, you know what? Let's take this from base 64 to hex, because I have a thought that this is going to be the TXID with the whatchamadoodle at the end, the output index. So if that's true, let's see. I want to go to, okay, base 64 to X. Okay. Interesting. Interesting that it starts with 0101, because we know that that's a pattern. But then this doesn't make sense to be an amount, but we are seeing some repetition. Let's see, do we see 88 AC? Also might make sense because you know how they sometimes do the hex hex. If we converted... Yeah, I don't think that would work, actually. Okay, let's see. Does anything here look super familiar? This kind of looks random. I was kind of hoping that at the end what we would see... Well, this would be Little Indian encoded, so there's no way that that's Little Indian encoding. I was kind of hoping that this would be the transaction ID. Also, this converter is wrong. So let's not use this converter because this converter is not converting from base 64 to hex. So that would be the reason why. I think this one, this converter, I believe, will do it. Okay, view. No, we want to decode. Okay, is that right? All right, so it would be interesting to know what this instant lock thing is, and be interesting to see another example with the other type. Because like we can skip. I mean, if this is all we need, you know, we get to skip a lot. It's great. Dang it! Now I've got too many things open again, and I can't tell which is which. So let me try to go back here again. Let's close this out. I don't think this is it. All right. So protocol 1, easy. Type 2, we know what that means now. So, it'll be good. I'll try to get this documented. Maybe I can do it on the repository that we're working on right now. And let's see if we can learn something about these here. So signature, public keys. Signature, do we have a signature here? Because I don't see a signature. I do see this transaction. I see that it's got, this is output index 0. I don't see a signature on here. Is the signature down here? Oh, signature's here. Okay, so the question becomes, what are we signing? So we need a serialization to get this signature. And we need to know, okay, so apparently it does need the instant lock. I want to see what the chain one looks like. I want to know what this data is. Can we figure that out? Does the WASM code have it? Okay, and then what does this public key represent? What is these IDs and purposes? What do they mean? All right, let's see if this takes us anywhere useful. The instant send lock. Okay. All right, so in view of this, I think that this is getting encoded This seems kind of dumb. I'm not this. Sorry, not this. But it, like, you just, like, the thing's gonna go on the blockchain. Like, why do you need to have all this extra hoopla? Just whatever. So okay, all right. Let me explain that. Let me explain a little bit. So there's a concept called eventual consistency, which was what I was kind of talking about earlier without saying eventual consistency. So the idea of eventual consistency is that I could send you a letter, and then I could pay the post office to send you a letter after I've mailed the letter. And in fact, the post office kind of works this way. So you may have gotten a letter before where the post office asks you to pay the money for the letter. So imagine a system like that, where when you go to check the letter, at that time, you would get the information about whether or not the letter has been paid for. Because you don't, since in the case of the post office, either the sender or the receiver can pay for the letter. And in the case of something like Instant Send, it doesn't matter whether it was on the blockchain at the exact moment that you click a button, or whether it's on the blockchain later, because it just doesn't matter, because you're talking about something that's going to persist for not only hours, but unfortunately years. So the idea that you'd need all this extra information for something that is literally only valuable for a matter of a few minutes is just silly, because you just reject the thing. You know, you float it and then you reject it. You know, if you just, it doesn't, whatever. I don't even know why I'm talking. I don't even know why I'm talking. But okay, let's go back to the good part. And let's see where we can go from there. So the good part is, it looks like this. Now, I don't know how to get the raw IS lock via RPC or P2P or otherwise. Oh, wait. ISD lock? Was it ISD lock? Did I get that right? Was it actually IS lock? Oh, whoops. Sorry, we need an IS lock, not an ISD lock. Wait, deprecated? Okay, so this is wrong. It's an ISD lock. Ryan, would you be so kind as to, wherever the heck the Git repository for this is, to reference this link and suggest that this is supposed to be ISD lock? I can only assume that that's what it's supposed to be. Okay. So this is also incorrect right here. This says array of bytes. This would be base 64 encoding of the IS lock. It is not an array of bytes, as you can clearly see from what we were just looking at. Where did that go? Unless we're looking at something different now. What we were just looking at, yeah, it was not a byte array. That was false. What we were looking at was base 64, and I believe that it was RFC base 64, not web base 64. Which it is important to distinguish between RFC base 64 and web 64. You can recognize them on site, especially for long strings where it's very evident when slashes are there. And then transaction also was not an array of bytes, it was hex. It's not that they were representing it as hex or base 64 for the purpose of printing it. It's that that is the way the message is actually sent as this is documented. But, okay. Core chain locked height. Why would you ever send this? If this is actually stored, which maybe it isn't, maybe it's just an ephemeral message and maybe that's why it doesn't matter. But if this is actually stored, this would be a terrible message to send. You'd only ever want to send this one. Okay, cool. All right, this is really helpful. Wait, this is also not an array of bytes. This is an integer. So yes, this documentation is, this is, yeah, very much draft state, which is fine. It makes sense for it to be in draft state. No one's ever used it before. Oh, weird. Oh, so these are very different. Okay, transaction output index versus outpoint. Okay, and then we are missing 4-byte output number. Outpoint, okay. And we don't have any example of what this looks like. This says object. I would think that this is actually not an object, but this is hex. But we don't have an example to show what it looks like, so we don't know. Oh! Signing! The signing is here! Oh, this is beautiful. No! 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 I don't think we actually need the BLS, though. Okay, right. Exactly. Okay, we don't need BLS. All right, signature to VAC, private key, data to buffer. Okay. So unfortunately, what we don't know is what to buffer is, but it's okay. We can go find signed by private key. We should find to buffer there, and that should give us the serialization. Let's see. We need to find serialization traits. So we can find to buffer. All right, so here's what I'm going to do. I'm going to look through everything that has a signer, and I'm going to look through everything that has to buffer. And then I'm going to sort. Well, I guess actually what I should do is cut -d sort -u. There we go. All right, now we're going to do com signer buffer. All right. Boom. So what I did was I said find every file that has this function, and then also find every file that has this function, and create a list with just the file names sorted alphabetically. Now subtract what is common between them from column 1 being what's unique to file 1, column 2 being what's unique to file 2, which leaves only column 3, which is what is common to both of them. And so in these here, fingers crossed, we will find the file that defines both signed by private key and to buffer. Now, we may not get that lucky because this might be an instance where things are signed in very different places, but that's my hope. Wow. Okay. All right, so here is to buffer, platform serializable. So this is our problem right here, right? So we have platform serializable, which is going to be some sort of abstract thing to work on state transition. So this is very frustrating because where we should see serialization defined would be in the state transition, because that is where serialization matters. Instead, what we're seeing is a platform serializable, this abstract thing, which means that we're going to go have to hunt for figuring out where this thing is created. You know, I'm just going to pick something at random that looks like, you know, maybe it could be useful. Platform serialization conversion. And this is probably going to have some macros in it. Yeah, so it's going to have platform version, self. Yeah, so now we're in that, we're back in the loop. We're back in the churn. Yeah, so this is really unfortunate. You know, you see this comment, like every single comment says basically exactly the same thing. Document follows a pattern, 32 bytes, encoded values, 32 bytes, 32 bytes, encoded values, 32 bytes, 32 bytes, encoded values. What 32 bytes? What ID is the 32 bytes? Now, in the case, we could think about this, what would this mean? What would make sense? Well, we don't know how to get the owner ID yet. We don't know what the encoded values are. And we don't see any reference here that would at all help us understand what those values are. You know, this is a trait. Okay, so the trait is implemented somewhere. So let's look for implementations. Again, let's try. Yeah, I don't even know exactly how to look for this. I'm not sure how we'd find it in Rust, but there's a lot of... Okay, let's narrow it down by this. It's possible, certainly possible, that the implementation would be declared as a function. Certainly possible. I think that's generally how you do it in Rust, is you nest things. Like I said, I was in the Rust community for a couple of years, but I only wrote a few Rust programs. Although I did write one that got deployed via Sonos. It was a trying time, and I don't remember it that well. Okay, serialize enum, serialize struct. Yeah. That's not good news. That's not good news. Let's go ahead and take a look at it and see what it looks like. Wait, were we doing serialized to bytes or serialized to buffer? I thought we were doing serialized to buffer. Am I wrong? No, it's serialized to bytes, but the method that calls serialized to bytes is to buffer. Okay. Serialized struct. Yeah, I'm just... This just makes me sick. The ability to trace down all this to figure out what it does, maybe... It might be a size big problem. Extract the generics. Yeah, we've got metaprogramming in here. I didn't even know you could do metaprogram. Well, I knew you could do macros, but this, what I'm seeing here does not make sense for what I know about Rust, which again is not that much. But to have some sort of, I don't even know, I don't know what to call this thing. Okay, this is not helpful. Okay, let's go back. Let's go back. Maybe code snippet with regard to signing. All right, the process to sign an identity, canonical CBOR encode of the state transition data. Does that mean the JSON? Okay, so things that we need to do. Owner ID, thing ID, owner ID, CBOR of thing. Oh. Okay. Let's just do a little search here for my friend JSON. I'm a little confused. Okay. All right, so we need to find, okay, so like again, this is a problem because what we're told is, hey, look, here's what the data looks like. Where did the one that actually had the data example go? Okay. Hey, look, here's what the data looks like. That's what we're told. But then, all right, well, you're going to sign the data. Well, I saw the data. You saw the data. Here's the data example provided. Here's the schema about the data. Okay. How do we sign the data? Well, you have to sign a CBOR. You didn't give me a CBOR. You gave me JSON. Well, let's see if we can find Seaboard. Actually, let me go see if we can find Seaboard in Kotlin, because I think that'll be easier to read. We can find Seaboard in the Kotlin code. Yeah, the Kotlin code has actually been quite pleasurable to work with. It's got some of the stuff that Java has, but I would say that from what I know, looking at the JavaScript code, looking at the Rust code, looking at the Kotlin code, to me, the Kotlin code looks like it was written by a Kotlin developer. Now, I could be wrong about that. The Rust code does not look like it was written by a Rust developer. The JavaScript code does not look like it was written by a JavaScript developer. But the Kotlin code follows patterns that I'm familiar with from what I have seen of Kotlin that I believe to be good Kotlin. Some of the abstract class stuff aside, let's see, who's this hash engineering guy? Does hash engineering work in Rust? I want to go find out what hash engineering does real quick. Because I wonder if hash engineering doesn't work in Rust. And let's see who works in this stuff. How do we see who? Well, ladies and gentlemen, and there we are. $1 million lines? Wow. A steep drop off. Okay, versus, now let's go look at this. I'm playing favorites, people. But I'm playing favorites empirically. I mean, I guess there's a manner of subjectiveness, but yeah, it's empirical. All right. Now let's go see here. Contributors. So if I were a betting man, I would say that whoever this person is has professional experience coding. And maybe this person too. I don't know. But just based on, okay, these code bases don't look the same. Or, of the code bases over here and the code bases over here, like there's something different. The difference is the person writing the code. It's not the language. It's the person writing the code. The amount of abstraction in here is only slightly obnoxious, and that is part of Kotlin that's kind of inescapable. You kind of have to buy into that when you start coding for Android. So you can manage it, but you can't get rid of it, is my understanding. And I could be wrong. But I don't think that Kotlin is a magical programming language. I think that hash engineering might be a magical programmer. Okay. Seaboard. Do we see anything with a state? I'm going to bring Seaboard out into its own thing. Okay, to JSON, to mutable map. Oh, interesting. Remove protocol version. Okay, so here's another thing, Ryan, to note. Um, okay. Payload map string any. Okay, so okay, let's go look at CBOR some more. Protocol version compact. Encoded.size. Okay, so if I'm reading this right, which I might not be, this might be incorrect code, this might be old code, but this is saying that the protocol version is not encoded with CBOR, or it is. This is saying to buffer, so payload, encode protocol entity, return protocol entity to buffer. Mutable map. Base object. Okay, so base object inherits from this. So that is actually, okay, that is reasonable. That is reasonable. It is reasonable that a state transition inherits from a base object that has to JSON, to object, to buffer, encoded entity protocol, where these are concrete and these are abstract, but the object can be implemented as to object. Okay, and we know what the object implementation is. Okay. This is functional code. We know what properties to look up. And part of this is, I believe, and I could be wrong, but I believe that Kotlin does not encourage you to do terrible, nasty things in the way that C++ encourages you to do terrible, nasty things. Rust does not encourage you to do terrible, nasty things, and neither does JavaScript. Well, in JavaScript, 50-50, but not that kind of terrible. It certainly allows terrible, nasty things. But this to object here, so base object, every base object, this makes sense. Base objects must implement to object into JSON. The to object that they implement is going to be what gets serialized. I'm not sure if this protocol version should be removed. Okay. I believe that especially if we had a Kotlin editor set up, we could reasonably navigate this code base and figure out how this is done. I'm going to ask, let's see. Let's see here. Okay, well, one thing we could do to wonder about, is it up to date? Oh, dang it. Last commit was a year ago. Okay, so the bad news is, what? Okay, let's say that the documentation over here is more correct, and that protocol version is included as part of the hash. All ST fields. It says ST fields. Now, the question is, what is an ST field? Because we have different hierarchy of object. Let's go back to our identity create state transition protocol version. Okay, so let's assume that this documentation is more correct. Who would know? Okay. Call me Schwarzenegger. Okay, done. What's up, Schwartz? All right, I did a search for JSON. Okay, let me do this JSON to Seaboard one more time, because it seems like... let's ask GPT. Search sucks. This is why we have GPT, because search sucks. GPT broke search by generating lots and lots of content over the last decade. And, yeah. So we're at where we're at. This is what I would expect. So why were search results only going in the wrong direction? All right, let's try npm. Let's look for Seaboard. With support for numerous tag extensions. No, thank you. Yeah, so this one You should be able to see the information about it once the chat disappears. This is Ender Lilies, the Glass Tower. Oh, I get it now. I'll be back. I think that would be Call Me the Terminator. You went past the abstraction at which, I mean, I get it, but I would have, yeah, I don't know. No, you did well. You did well. I just didn't get it. Because if you said Call Me the Terminator, or would it be, what's his name was? I don't know. Whatever. The chat, by the way, worked perfectly fine. What chat did? Oh, yeah. Yeah, it works. Oh, okay, it was working before? Great. No, I think it was good. It was good. Okay, too many things. Okay. I need browser Cbor. Does this work for browser? Does it work for browser? All right. Seaborg. I like strictness. And that's a lot of weekly downloads, though. Usually things that have that... Oh, it's RVAG. Okay, that's why. I was going to say, normally things that have that many weekly downloads aren't good. But I think we can trust RVAG. Trying to remember, what else did he do? Let's go look at it. See what I recognize. I don't remember remember where I recognize him from, but I think he's one of the good guys. I have a positive association with his name. Okay, that might be why right there. I actually want to go as far back as I can. Okay, he does Mac stuff too. He does some stuff with OpenSSL. Oh, he did stuff with Bootstrap. Or, well, he forked it. That doesn't tell us anything. Oh, Ender! Okay. Wow. Blast from the past. Okay. Ender was a JavaScript framework. I don't remember exactly what style it was. It may have been maybe jQuery-esque. But I remember using it once or twice, and I think I had relatively positive feelings about it. Thank you for the many blessings. Okay, Sainver. Yeah, okay. Yeah, Craftsman. Require.io. Okay. I don't remember specifically what are all the things that CSV2 why I have trust in his name, but I know I've seen him around and I know that I've used his stuff. I think that he does good. That he is one of the good ones, not the evil ones, I think. Ah, look. Zero dependencies. Yeah. So okay. Let's see, does he have a dist file here? Oh, that's too bad. That makes me sad. That makes me sad that he's doing one file per function type of stuff. But perhaps when we install it, because we have to make sure this stuff is going to work in the browser. That's pretty important. Do we not just have like a JSON, like a straight do JSON? Okay, encode object. And then options. Okay. Yeah. Okay. All right, this is basically what I think I was expecting. UN 8 array. God bless you. Okay, let me check. Chat. $22.53. It's a bit time to finish the solid plan. Did you manage to do it? El nah. Oh yeah. Hey, that's what I like to do. I like to say bless you and your wives and your children. Oh, I'm AJ. Yeah, Ender was reference to Orson Scott Card's Ender's Game, but it was a JavaScript framework. The no library. Oh, okay, and he was the one who was primarily creating it, maybe? Maybe the Wayback Machine would have the homepage. Oh, it was dependency management. Okay. Oh, I think I remember. I think that this was something similar to what I was doing, where it would read the file to determine what the dependencies were. Maybe that's what it was. Yeah. Can be used by the browser. Okay, yes. Yes. Okay. So I think that our approaches were similar in that we actually look at the file, figure out what the dependencies are, get the stuff, and then copy and paste the files together. Yes, 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 yes. Okay. Yeah, and yes, it was the break away from jQuery, make it smaller. So, yeah, okay. Okay, yeah. So it was like a kind of like a browser registry thing. This is way back in the day. Way, way back. I remember this though. I remember this. This was back when I used to have positive feelings about projects. Back when people were trying to make things simpler. Uh, yeah, and then there's this guy. He's disappeared. I don't know what happened to him, but I have not seen him in a long time. Yeah, I don't know what he was all over the place doing all sorts of cool things. And then he just disappeared one day. All right, Seaborg. I think that this is what we need. I'm hopeful that if we install this, that he had the good grace to publish it in a way that we can use. So let's go back over here. Yeah, capital A, capital J. It's A stands for angry and the J stands for jaded. Used to stand for awesome and just doing my thing. But then the world ruined me. And now I can never find happiness. That's weird. How did I end up with Seabor? Seabor is not a dependency of Seaborg, right? Hold on. Let's look at package log. gRPC common needs Seabor. Okay. But I thought Seabor didn't work in the browser. Okay, let's give Seabor a chance as well. Do we have a dist? Oh, something's making me sneeze. All right, so bad news is I don't see here a browser file. So that makes me want to go switch over and take a look at this. This one's definitely Node. Okay. So do we have a browser-friendly version of Seabor? Can we look for Seabor in browser? Okay, why does he have a patch to this? Let's see what that's about. Okay, ellipticoin. Yeah, it should be synchronous. I don't know why you'd need to be asynchronous for something that's just iterating over a JSON object. That seems kind of silly. All right, let's see if we can figure out what this is about. It's not really him, is it? Isn't that like a TV show dude or something? All right, so he does not have his fork visible. Okay, ellipticoin. They say browser compatible. What? I'm so confused. All right, this looks really simple. I like it. I just want to know, does it work in the browser? Okay, so it's got a little bit of hoopla, but it looks like it'll work in the browser. Oh no. Wait, what's this buffer writer stuff? Oh no. Oh no. You've got to be... Come on. Come on. There's got to be a browser-compatible version of this thing. Okay, so it looks like... Oh, they've re-implemented the entire buffer library for this. That's frustrating. Okay, let's take a look at another one. We're going to find one. We're going to find one that is browser compatible. Okay, let's take a step back. I'm just going to close out a bunch of these tabs here. Close this out. Now, that one's called Node CBOR. I'm guessing that they do not have... Okay, CBOR Web. Okay, good. All right, this one looks like this might be the right thing. So Node CBOR has a thing. Okay, so we're going to install... okay, so let's go look here. So under Node CBOR, there's lib... What? Where is this not the right one? Is this not? All right, CBOR property on the window object. That sounds good to me. I like that. So this is okay. It's got its own package.json. All right. So one day we'll have to rewrite CBOR for modern JavaScript, but today is not that day. I mean, it looks so complicated from what I was looking at in that other one. Let's see. Let me just go in here. Lib CBOR. Export CBOR from CBOR. That's redonkulous. Seriously, do we not have like... we don't... Alright, uint8 array. Alright, we'll use CBOR Web. We'll use CBOR Web for now. But I'm finding it hard to believe that we've got an RFC spec thingamabob. Yeah, most of this seems to be re-implementing the buffer APIs. And we don't need those. It looks like there's some sort of maybe a varant style of thing here. Data is false, data is true, data is null, data is undefined. Data is number. Data is big int. Okay. So I think essentially, this looks like pretty clean code here. I bet essentially we could take the encoder Let's see, encode. I'm not going to do it now, but I just want to take a look at like how complex is this? Because I think all we need to do is take the encode, and then we just need to go through and just swap this out for data views. In fact, I'd be interested to see, let's see, encode, writer functions, func, writer, func, format, I writer functions, dot length, encode writer, return write result, unsupported format. I don't even know what that means. Oh, it seems like that. If you're going to do it dynamic like this, you could simplify it with a map. But I just want to see what happens. I'm just going to throw this in. I'm not going to use it. I just want to see what happens because I think this could actually work out really well. Okay, we don't need any of that. We don't need any of that. Okay. See here. Yeah. Is it just spitting out the same thing that I just put there? No, read byte. Got it. Okay. Interesting. I don't know if that's a real thing. Can write binary. Anyway, I was just kind of curious to see how I do it. Looks like it did a pretty decent job. Probably not perfect, but... Alright, so we're going to do npm install save cbor web. Or was it web cbor? Let's go double check on that. Okay, where's my issues for this thing? You know, one more thing I'm gonna try while it's on my mind before I move entirely on from that. I tried this one time, something like this one time, and it worked amazingly well. Okay. Huh, okay. Yeah, not quite. New Seaboard encoder. Okay, let's see what it does. Buffer is an array. That's not right. Encoded value. Interesting. This might work. I mean, can you imagine that? The code that GPT spits out is cleaner than any library on NPM. This is you know, this is not bad. It may not be correct, but it looks like it certainly could be. Oh, I'm just going to post that in there just in case. So back in the 3.0, 3.5 days, if you asked it a question like this, it would literally just it would hallucinate requiring a module or importing a module and then just wrap it. Like what you see here. I think that might be correct. I mean, it's hard to say, but there's at least we've seen a dozen implementations already, plus there's probably a dozen implementations in a dozen languages, so oh, okay. There's something there's something interesting. So this may not be syntactically correct. It might be pulling from Ruby or this may be valid in JavaScript now. I remember um, seeing something about that, but okay. Anyway, all right. Enough of that. But yeah, we do want to have a web-friendly Seaboard library. We don't want to be using something that is transpiled from Node or has to go through a bundler that adds an extra 15 megabytes of webpack to it. We want something where it's just give me the goodies, you know? All right. And this one appears to be that, but about 2/3 of it is just buffer implementation. All right, this is Seaboard Sync. Oh, this one only has 99 downloads. That's a good sign. This might be really high quality. Is this one Ellipticoin? Let's. Did we just look at this one? Okay, yeah. This is the one that was. Yeah, it just the problem is that it's re-implementing the reader and everything. Okay. Let me. I forgot where I had my issue open now. Okay, that's the one that okay, that is the one that I already picked out. Great. And was this the one that we pulled from for the web version? No. 6 years ago is when this was updated. Okay, yeah. And we could probably find some unit tests for Seaboard pretty easily and know that we pass things. That's another thing. Okay, so this we could do later. All right. Let's back it up, back it up, back it up. All right. Get the user into the pit of success. Stat. All right, identity key. Okay, back off of that one. Okay, back off of that one. We can leave that up for now. I think a lot of this stuff we can leave up for the moment. Let's see. That one, we'll leave that one alone. I'll just take down a couple of these because I'm not using those right now. And then let's get back to this bit here. Okay. If I can remember what we're doing. All right, so now we need to be requiring... I have faith that we're going to be able to use Seaboard Web. Okay, so is this the legit node Seaboard? I just want to... because we're looking at so many of them. Seaboard mono repo. Ugh. Threw up on my mouth a little bit there. In case you couldn't tell. Okay, this is Seaboard. This is the... okay, I just want to double check because supply chain vulnerabilities and all that. I want to make sure we're using the legit Seaboard, the real one. Okay. This is the real one. Okay. All right. Just wanted to make sure. Pants button is digging into my belly because I'm fat. You know, I do have to say, I think this approach is quite right. It's a pity that the other ones didn't use that approach. You know, I wonder if GPT got this code from somewhere, because this is far cleaner code than most programmers write. It's only got a tiny itsy bit of unnecessary abstraction. Like, that's pretty good. Like, this seems better than the source material. You know what I'm saying? That's an unusual thing. All right. Oh, flippy dippy. I don't know how much I've got left in me. Seems like we're really close. We're about 4 hours in. Not quite 4 hours in. But I lost steam before I started, so... What do they call it again? So there's our ISD bytes, right? Okay, identity ID. Oh, best viewers. Oops. Here, what was the data for the identity here? Okay, so maybe these keys are arbitrary? I don't know what to make of this. Balance, revision. Revisions, generally speaking, are a bad idea. We're talking about an append-only log here. I might be wrong about that, though. I might be wrong. I'm not sure how this thing works. Maybe the revisions actually do make sense because maybe there's a vacuum function. Okay. All right. Uh-oh. Okay, this is good to know. All right, so public keys. Oh. This is so dumb. Why would you put integers on a wire protocol in JSON? Why would you do that? Unless they were actually representative of integers, in which case I'm in full support of that. But it's JSON, it's JSON, people. I mean, why bother having keys at all? Why not just name the keys 1, 2, 3, 4, 5? And these are different 1, 2, 3, 4, 5s than the ones I was talking about with the tests. These do have meaning. It's just you have to go look it up in the code. This is the schema, but the schema doesn't define what the meaning is, which is my problem with this. Okay, so the schema has a comment as to what the meaning is, which is good. But this is silly. This is silly because you're just off, ink, deck, withdraw. I don't know. Just whatever. Okay, so, but the good news is we're finding lots of good stuff here. So okay, so I do think that in the example I saw, I don't think that the ID means anything based on this. So this is good documentation to help understand that stuff. I mean, it's pretty good documentation, period. It's missing a lot of stuff, but it's pretty good. Like this has important things in it. All right. But the message format across the wire, the enums should be strings. Now, if you want to, in the binary format, if you want to reduce the enums back to something else, I don't know why you do that. I don't think there's the savings there that you think there are. But you know, let's say that whatever, you decide to do that, then do it down at the binary level, the storage mechanism, the database, right? Like you put the enum in the database, let the database handle the enums. And then you know, now it's your problem to figure out how do you handle enums in the database. And pretty much every database, you know, like pretty much everybody says just don't use enums in the database, because by enums I mean reduced enums, integer enums. Don't use integer enum mappings in the database, because it always something goes wrong and then it fails. So you just use strings, and if you need to create a constraints table, you create a constraints table. Or you know, if you need to have a code that has the map in the code, that's fine. But just yeah, but that's not wire level stuff. Okay, public key, security level, read only. So identity balance, that doesn't make sense to be. That doesn't make sense to be a property here, because that's a computed property. That's not something that you can submit as a document. Okay, maybe that's just because that's at the top level. Okay, so what do they say the ID is? Oh, okay, so it's an address. That, like, could you... Oh, I guess they're not going to call it an address because it could be BLS. Is this of the master key or what? Oh, no, it's not. It's not. Never mind. It's not. I was wrong. And I don't know why they do the SHA-256 stuff still, because the whole reason for the double hash does not actually apply to SHA. That applied to MD4 or whatever it was. So this whole idea of doing a double SHA is, it's like this, it's this legacy thing that, you know, just get rid of it. Get rid of it at this point. Just drop it. You don't need it. Identity, create funding output. I don't know what that means. I don't know what funding output is. I think it means the asset lock. Well, that's nice. So I'm not sure if that's... I don't think that's part of the transition state. Okay. Okay. Okay, and that's 32 bytes. Good to know. Okay, and what was used for the signature again? Okay, so I want to find the asset lock stuff again and document that. Okay, wait a minute. Hold the phone. This doesn't make sense. This transaction is not an asset lock transaction. Look at that. This is not an asset lock transaction. Yeah, I've got very low confidence that I can recreate this stuff at this point. Because, yeah, the code's... The best code I found is a year out of date. And the documentation... It'd be interesting to decode that. So... Ugh. All right. Well, cool. I mean, I'm feeling better about this. It's just that everything's inconsistent and wrong. That's all. I think I can kind of sort of recreate this. Let's go ahead and try it now. I've got stuff documented so we can pick up where we left off. I've asked the right people, maybe the right people questions. I don't know what you do with these keys. Oh, wait. Oh, there was two more things I was trying to look up. Hold on. There was the asset lock proof. So we got two of them. We got this one. All right. Do you ever want that other? Oh, okay, cool. So good news. All right, so yeah, this is it. This is the good. No, not this one. No, this is the good stuff. Oh, that's too bad. That's too bad. Yeah. Mono repos suck. Hey, look at that! Oh, man! Wow! Could it be any simpler? No, it couldn't. That's... Oh! It's beautiful. Okay. Cool, cool, cool. It's beautiful. Wow. Look at that. It's got the whole thing in a single file. There's business logic in the code file. It makes me want to cry. It's so beautiful. It's a double rainbow. What does it mean? Oh. Oh, man. Um... Okay. All right. Let me see if I can actually get to implementation. I'm I think I'm at the point where I could be there. It's just, um. All right. So that we're gonna do the dry run of this with the asset lock proof as by height. Okay, so let me flesh these out. What have you? Got too many things. Too many things open. Alright, let's get rid of that garbage. Okay. Where was I? Alright, getting rid of this. 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 Nay. Okay, I already got the good stuff there. Alright, hold on. Okay, let's see. Oh no. Hmm. Okay, so here is... What? There's no... Again! There's no code here! Okay, so, backstory. A very short backstory. Shimnick sent me this and says, I think this is where the conversion starts for the Seabor. For... There is... Okay, so notice how there's dozens of files with this JSON conversion thing. Ugh. Garbage. Absolute garbage. Okay, let's take a look here. Okay, this one might have code in it. Yeah, okay, so this is where we have the problem. Is if we have to, okay, yeah, this is where the JSON implementation may need more love. Because if we do run into these problems where you have to specify I64 versus Clone64 versus U8 versus U32, all that stuff, right? That's where, and then we did see something that had, well, it was in this one, right? So under DPP, source, main, proto. Okay, so what we see here is we have int32s and an int64. So this is where the CBOR thing matters. Okay. Is this okay? This is nothing. Are these even functions? Okay, this is an implementation. Okay, but what does it do? It does nothing. It does wrappers. Is it even doing anything? Okay, from Saturday. Okay. Okay, what did okay. CBOR data types. Okay, so this was wrong. Okay, I got confirmation that this proto thing, where's proto dot proto. Okay, that was wrong. Anyway, there's a proto thing that is wrong. Let me go back over here. Okay, that's wrong. Okay. All right. All right. Sorry. I was looking at messages. Okay, so that was important information that I don't know. Okay. All right. So the important information is that I do need to make sure that there's a few types that do need to be put across correctly. So it looks like Cbor should come across straight as JSON, except for the big int type, which I don't know if we have a way to do that. JSON big int. Uh-oh. All right. Oh, what's up, Josue? I'm immediately going to sleep, but want to say hello since I saw the stream. It's been a while. Yeah, well, I'm back. I'm back. I'm back, baby. You have a good one. Oh, you're also around. Cool. Yeah, I'm kind of like I don't want to dig into this right now. Maybe JSON value string, JSON value. Okay. So, good news is first it goes to JSON, then it goes to CBOR, right? Is that what we're saying? So, do we have big int? Or do we just have object? Yeah, everybody has a hard time reading the Rust code. And I don't know that it's Rust's fault. Some of it is Rust's fault, though. Some of it is. Rust is often it can be very pretty, but it also can sometimes be a little rough. But yeah, it's not. Yeah, I don't know. I have mixed feelings about Rust as a language. Anyway, okay, I don't want to look at that. I want to look at the one in Kotlin, because the one in Kotlin makes sense. So if we go here, state transition. I think I saw the CBOR stuff already. I'm going to go back up here a little bit. Oh, we don't... Wait, where'd the CBOR go? That's weird. Where'd sign go then? Oh, it's indexing. It's being indexed. That's what it's telling me. It's indexing right now. Okay. So, all right. Okay, let me try one more thing, and then I think I gotta go, because I'm just like at this point I don't know that I'm making progress anymore. Oh, I was gonna fill this out. Now, I mean, I have been making progress because I was talking with people on chat, and people on chat know things I don't know. So there's that. Okay, where is instant send and chain proof? Okay, so here's what we need for this. I do want to get this down. All right. Oh, my my complete that I thought was on here isn't on here, where I can just hit tab to complete any word that I've typed before. I rarely use it, but I just want to use it now. I have to check on that. All right. You're a wizard, Harry. Do magic. All right, so there's get blockchain info. Let me just go do this again real quick. Where was it? Because I think what I'm going to need to use is the height. By blocks. Okay. Also found some transitions goes through generic JSON CBOR, but some have their own implementation. Yeah, I just... Well, I'm hoping I can find it in here. Okay, there we go. Now this is showing up. Okay, cool. So I say we look at this code. This code is either correct or will become correct, and this code is super easy to read. So the base object... All right. Okay, this one still seems... Yeah, okay. So he's still got removing protocol version in there. So maybe the documentation's out of date. Maybe... No. Oh, dang it! I'm in the Dash Pay one again. Okay. All right, there we go. Anyway, so I'm over here. Where was I? What was I trying to do? So trying to look at this information here. Out point. Now it says object. That doesn't quite make sense to me. TXID vout. Okay, TX draft. Oh, okay, here's what we need to do. Okay, dash tx dot sort inputs dash tx dot sort outputs. So oh, whoops. Okay, good. And then from that, we should be able to find the V out, right? So here's our transaction draft. Wait, I need to go fix something down here. Wait, what's this saying? Oh, whoops. I got it. Not the first time I made that mistake. Won't be the last. Okay. Let's lift this up a little higher. I kind of want this to be all the way up here. All right. Okay, so what's not clear to me is it does not say what an out point all right. Doesn't what in the world? What is going on? Aha! I knew it! I knew it! I knew it! I knew it! Who knew it? I knew it. Look. Out point. Okay. Out point is not an object. All right. right, so here, outpoint type array, byte array. This is confusing to me. How do you know? Let's see. What's up, Amlin? Yeah, so it just says byte array here, but it's obviously not a byte array. The question is, does it want hex or does it want base 64? Also, we have to go look at where there's base 58. Okay, where's the base 58? ID, blah, 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 blah. So I'm going to guess that it's going to, I'm going to guess that in the schema, it's going to call that a string. No, look, it also calls it a byte array. Okay, let's check out Platform Explorer. Maybe that is junk. The documentation here. Maybe the documentation is junk. Let's look at Platform Explorer and see if we can find data contract schema that's I would assume must be up to date. How do we do an identity? Identity? Alright, associated transactions, data contracts, and stuff. Where's identity? Shemnik? You know? Okay, this doesn't look right. Meh. Okay. Wait, let me see if I can find this in Dash Tools. I mean Dash TX. Nope. What am I looking for? Get ID. Yeah, I'm not sure if this is the right order or if we need to... Why did I create that? There were things where we needed... Okay. I think I might have to create another one called Get TX ID. Because I know there's an instance where we need one and there's an instance where we need the other, and I don't really remember. It seems like we could produce these keys, all the way the heck back here or something. Okay, so DPP keys are up there. Or maybe, I don't know, maybe we bring them down here. Alright, so let's just double check on this. What this says. Yeah, I'm gonna have to go to bed soon. I can't keep at this. Well, we might be really close. We might be. Or we might be really far away. We don't know, because we've got no examples of data that are consistent. We do have examples of data. which is why we might be really close, because I think we can replicate a lot of this, but this is confidence that this is accurate, very low, very, very low. Okay, but yeah, and then this one, wait, let's just double check. This one's hash engineering. Where's base object at? Identifier. Okay. So this is the newest one. This one still removes protocol version before encoding. So I don't know what to make of that. When was this file last edited? 3 months ago? CBOR encode payload. Serialized data. It's not really serialized. It's 2 object and 2 mutable map. So I would not call that serialized by any means. Okay, but this makes perfect sense. This, I think, is our target. So if something has a special toObject, like this is the good news. We can look for a function called toObject, and if the toObject has something special in it, then we know. So we can go back to DPP here, and we can just search for toObject, and then we can see ID, public keys, balance. Whoa! How can we possibly know what the balance is, though? That doesn't make sense. Do you rewrite your identity object every time you use some of your balance? That could be a thing. That in order to spend your balance, you have to rewrite your identity object with less balance or something? Anyway, this just looks good. I mean, look how clean that is. You can find everything. Okay, that one's a little abstract. Oh, it's called abstract document. Okay, let's go back to state transition and look at it. All right, toObject, skip signature equals false. Skip identifiers conversion. Override open. Oh, okay. So the internal versus external. So this is I think this is the public method. Is that what we're saying? And then this is open, whatever that means. Okay. So this overrides the abstract. Creates a hash map, sets protocol version, sets type, sets signature, and returns the object. What about the other parts of this, though? All right, anyway. Okay, let's look at this. So did we finish our chain lock mabob? Okay, so it has a type, it has chain lock, and it has out point. That's it, right? Boom. So this one, for the instant lock, again, I'm not actually sure how we get the ISD lock. RPC. Meh. Deprecated messages. So that might be something that we can only get over ZMQ. Or maybe P2P, maybe an inventory message. And what are we looking at here? P2P. Okay. So is this an inventory message? Is that the type it is? Okay. Mm. All right. So then the question becomes, how do we get ISD lock messages? How does this code do it? Pre-mempool sent instant lock listener. Looks like it might be helpful. Okay, so I think we do need to get that instant the ISD lock message. Okay, we're going to skip that then. That's not something we can reasonably do right now. I wonder how this is done. Like, how is this, So ZMQ? Is this ZMQ? All right, it doesn't matter. The point is, we can't get that right now. Let's look and see if we got any ZMQ documentation. Our P2P networks. Where's ZMQ? Okay, so ZMQ has a lot of the same stuff as P2P. So we probably should not invest too much in P2P. We need to have P2P to send to the master nodes for CoinJoin, but we probably should invest more into ZMQ in terms of our own tooling. Okay. There we go. Boom. You know, it'd be cool, and maybe better than cool, maybe useful. Uh, to do something like this. Listen for the events, but have a function decide which is the one we actually want. But the function would need to be synchronous, not async. I think. Anyway, something like that. Hmm. All right, so something like that. And let me see what else was there. There's still one other thing that I keep on failing to finish documenting here. Okay, then transaction. And then what? Output index. This is so weird. Why do you have so many ways of doing the same thing? All right. All right. So there we are. Okay, so we got to get back to that signing bit. And now we got to have some sort of double SHA business, right? This is the asset lock, is it not? I think that just means asset lock. I could be wrong. Uh-oh. Uh-oh. Okay, so maybe the double SHA is all right then. Hold on. Text to bytes. Double SHA, reversey. bytes to hex. Okay. Let's go to any of our favorite sites. Let's do a little dash join real quick. All right, let's do a little console.logging.logface. On dash keys. All right, let's see. Okay, cool. Okay, good. So the good news is I did not abstract that too far away. I kept it clutch, as they say. We'll have to double check that this is supposed to be bytes. Like I think it is. Okay. All right, identity ID. What the flippy dippy do we do with that? I don't know. But we need it. Okay, now I get why it says asset lock proof dot create identifier and why that's identity ID. Okay. And then do we have a subtle dash keys dot sign or something? All right, let's see how QUtils is going to work. All right, so state transition. Let's see if we can get that down, what that actually looks like. Okay, and this data is going to be a base 64 encoding of the compressed public key. be here. That's the best I got. It's for all my friends. And my frenemies. Oh, this might be type. But we still don't know what type that represents. Public key, magic number, type. Does the public key have a type? It does have a type. Yes, the problem with these is that it's bogus data. We need real data. Like I understand you prototype out with bogus data, but we need real data. And obviously that data is better than 1, 2, 3, 4, but we need real data. We need real data. Like the real stuff. Hardcore. Parkour. The data. The real data. Let's double check here. Type. Instant lock. Transaction. Output index. Yep, that's it. All right, well, there we go. Okay, so these IDs literally meant nothing. All right, 145. What did I miss? Did I forget to return something? Did I maybe forget to return, the value? I might have. I might have forgotten to return the value. Happens to the best of us and the rest of us, don't you know? All right. Sorry. Just every time I look at this, it it's still frustrating. Why would you put integer enums in JSON? Put it down in the bytes, put it in the database. That's a database optimization. That's a table optimization. That's not wire protocol crap. Well, wire protocol is the good crap. Eight. Okay, so we got another problem here. We got get keys for identity as just using junk. I can't believe it. It's like you put the JavaScript object into Rust so that you can iterate over the JavaScript object in Rust and pass it back. Why? Why? All right, so we got to figure out what security level. Wait, they all have security level, but they don't all have purpose. Okay, so it's authentication by default? Is that what we're to understand here? Is there a null value? I don't think there's a null value on these. This is a security smell, by the way. When you see things like master, critical, high, medium, for in the modern age, all security is the same. There is no level of security. There are hierarchies of key generators. So there's a root key generator, and then there's a root authority. But you don't like, I don't know, maybe that's what this is supposed to mean, but when it says high, critical, medium, those aren't real things in security. Because in security, in real security, everything is just the max in digital form, right? If you're either going to encrypt it or you're not going to encrypt it. You're not going to like somewhat encrypt it. So that's a security smell. I mean, there are areas in which you do distinguish, but for all practical purposes, no, that's you don't do that. So I do wonder, what is the default purpose? Do we have a default purpose? Let's see. Wow. Hallelujah. That can't be right. Okay, it can. Let's see if there's anything about default. Well, that's sad. Another empty file. Looked like it might have even had some stuff in it, but no. Okay. All right, and again. Okay. I'm guessing authentication is the default, but I need to see a constructor. All right, so I'm going to guess that I think it's very, very reasonable to believe that the default is authentication. My frustration with that is that we don't know if it's true. Okay, platform version. Okay, there we go. There's our magic version. We found the magic version. That's it. Oops, and I made the mistake of saving. Where's my kill all Vim? Oh. It's too hardcore. Needs -9. Tried to be polite. Couldn't be done. Okay. So there's the constructor. Purpose. This is so dumb. This is so dumb. This is so dumb. This is so stupid. This is so stupid. You create the object over in JavaScript. You have these functions and these properties on the thing in Java. You pass it into Rust, and then you decorate it with all the same crap, and then you pass it back. So literally, instead of, I mean, like, this is so dumb. It's not like it's got some unique property. It's not like, oh, now that it's in the Rust code, it's going to do the Rust stuff. No, it's like, I don't know how to explain this. It's not just the same amount of work. It's more work. And it's not just like it's more work. It's more than more work. Okay. Because you define it in Rust. Great. You got a Rust object. That's fine. But then you bind it. And then you have to duplicate everything through the binding process. But then in JavaScript, you still have to do the same thing. This is like, like, Somebody needs to get a spanking by John Osterhout. I mean, I don't know how to explain this. Okay, so in JavaScript, you're going to have to call a set type function. So you could have just done transition.type equals create identity, just like I'm doing, right? But you create a binding, and then you still have to call set type. You don't get away from it. You still have to call it. And then you have to also turn it into a Rust method. So you call the JavaScript from Rust. This is like, it's a toy at best. It's a toy. It's like, oh, I wonder what it would be like to, this would be interesting. It'd be kind of fun. But look, all of this, or, oh, sorry, not that one. That one actually does something different. But there's no unique value. Okay, that's what I mean by useless abstraction. When we talk about useless abstraction, the abstraction provides no value. So when you have to pass in the same number of arguments plus or minus 1, when you you end up writing, not just like, it doesn't, I don't know how to explain it. Like, it doesn't save anyone any time. It's not better for the web developer. It's not better for the Rust developer. This benefits no one. There is no, so let's say, for example, but in Rust you can set read only. Well, but in JavaScript you can set read only. In Rust you can make sure that it's an integer. Well, in JavaScript, that you can make sure it's an integer. I mean, you don't even have to use TypeScript. Just having the linter turned on, it'll tell you. I mean, it's the TypeScript linter, but still, you don't have to be using a TypeScript file. You don't have to be invested into TypeScript for it to tell you, hey, this thing was a string, now you're making it a number. That's, it's just stupid. This is the kind of thing that you put together for a conference slide, like a hello world, right? Like, well, how would you write a WASM binding for JavaScript? Well, let me show you. Here in JavaScript, we could set hello by doing hello equals hello. But if we wanted to do it in Rust, we could do it as hello equals hello. Like, this is negative value stuff, and the deeper I go into it, because I honestly thought, 2 days ago, I honestly thought that this was going to handle some sort of relatively complex process, and it does handle a complex process, but not to get a result. I thought that there was going to be something saved, that there was something going on in here, some hashing, some signing, but there is signing, but it's not. You could make the argument that for the one thing, signing with BLS, you could make the argument for signing with BLS, or getting the public keys, but then just expose that, sign with BLS, and that But that's what it already had in the first place. It had that before the Rust stuff was ever here, because the BLS, the Rust stuff doesn't even have the BLS. It's not even there. It's still C code, and it's not even, it's like it whatever. Okay, but the good news is now I know what this means, kind of, sort of, in a way. I don't know what to do with it. All right, where does it set it to? Platform version, default versioned into default version. Yeah, I don't know what to do with that. Because it doesn't seem, is that is part of this object? Yes or no? No, it's not. It's not part of this object. So ID, type, purpose, security level. What was type again? What were our key type? Oh, type is ECDSA. Okay. So ID is truly an arbitrary number. It has no meaning. Type is ECDSA or BLS or script hash. Pay to script hash. Purpose is, I mean, they're kind of reinventing web crypto here, which I think most people agree that turned out poorly. Because what you end up doing to get around, so security should help you fall into the pit of success. That's the primary role of security, is for you to fall into the pit of success. Because anything that takes you out of the pit of success and thrusts you towards the jaws of the gaping jaws of failure, you're more likely to have security problems. So you don't actually want to have a bunch of this complex stuff. You want to have, like I was talking about earlier with the bus and the car, be like, okay, it does make sense to have, so for example, a root key or a master key, that makes sense. But like critical, I don't know. Let me read up on it. Let me see if there's some rationale. Why is there a critical and a high and a medium? Because it could make sense to have more than one key. But more likely, what you do is you do. So for example, you could have derivation, like we have with the HT paths. So you could have derivation, and then, and this is also how TLS works. Not really, but you can use a key as a master signing key, and you can sign other keys, but you don't designate. You just add a key or revoke a key. You can give a key certain properties. Say a key is for this or for that, but I don't know. I don't get what this is driving at. There needs to be something clear about what is the purpose of this. Okay, like this master key makes sense. So if they renamed these to make sense, master key, sure, root key, whatever. So, if this description is signing and this description is session and this description, but I don't know what this, like, I don't know. Dip 11 identities. And that doesn't really sound like a key type of thing. That sounds more like a like application thing. Like for example, when you go on Amazon, like this, you don't select a different key based on what you're doing. well, maybe kind of in a way, but it's related to the session. It's not like you don't use a different password to do different things on Amazon unless you're talking about AWS and you have a separate account because it's a separate product. It's a completely different thing. It's not a single sign-on with the shopping site. But, with the shopping site, if you want to go change your billing address, you have to do an additional step of verification. And anyway, I don't know. Maybe there is something to this, but just the names are very poorly chosen. And it should be root signing session and access, maybe. But I think you put that stuff to the application. Well, we've already seen how this worked out with Bitcoin, right? There's all these different options, all these different signing types. And in the end, you really only need 2 or 3 of them. But anyway, all right. So we made a little bit more progress. It looks like we're going to be able to fill this out. So let me go back and look one more time. Flippy dippy. Okay. ID type. And then read only. So maybe this is another issue we potentially have. I'm a little worried. That there's some default logic that I'm not catching. Okay, ID type data. That's all the properties, right? Yagni. Okay, maybe this one explains. So authentication is higher than encryption and decryption? Because the thing is, and I might be wrong about this, all your keys are generated from the wallet. If somebody gets your wallet, they get all your keys, right? And your keys are being used within the application, so it's up to the application to decide these things about session and such. It's not really for the key to dictate the security policy for the user. It's up to the application and the user to dictate the security policy. So that the application should have some perhaps guidance or something, but it's not like, oh, I'm using a signing key in this application, therefore, this is a really risky operation. Somebody could get this key. No, the key's on your device. Now, I think there might have been something here about using keys off device. So you could take a medium key and use it off device. Whatever. Okay, so the thing that I need to know is there a relationship between these default values? Because it doesn't say what the default value is in the schema, and I can't figure out where when we look at, what was it, this one? Okay. I can't tell from this. I can't tell from this that there's any default value. Yeah, I really can't tell how to make heads or tails out of all these different files with all the same name. I don't know. Yeah, whatever. Okay, moving on. All right, so one more time with this. So we've got ID, we've got type, we've got purpose, we've got security level. We don't have data. And I suppose all of these must have to be set read-only to false, but I really wish I could see where's the default value. I mean, I may have just looked over it. It may have been, let me look one more time, because my eyes just may be glossing over with the boilerplate. So let's look for example, true. Is the word true anywhere on this page? No. Okay. How about, let's say 1. Nope. How about 0? Version is being set to a string of 0? Interesting. I thought that was not a string. Or is it saying it's going to output a string? Creation v0? I don't know. Yeah, so I don't know where any of the values are actually, I don't know where anything's actually happening. Alright. Okay. Alright, so we got that. So then we need the data. And the data is going to be pretty simple. There we go. Key descriptions. Key description of key. You know, okay. Right. Okay. So first we got to go to binary. So for those of you that don't know, binary is a type in JavaScript, which is it's a special type that is essentially an what do you call it? An unencoded string. Still am struggling to figure out how to explain the WASM bindgen thing in a way that might make sense. I don't really want to. I just yeah. All right, cool. So now okay, so the DPP keys. All right, so now we're going to break that down into get identity keys. If I can remember where the heck I am. and identity transition keys. Okay, so maybe all right. I'm going to back this up. I'm going to back it up. So let's say this. Let's say actually, with our key descriptions, so here, all right. So we're gonna assign. I don't mean to do any of this. This is one of those things that the AI tools is really good at when you've got something right below that you're copying over and over again. I could save myself a good 47 seconds here for sure. If only. All right. So here we have the the distinction between what does this return? All right, type def evo key at prop. I don't know. I'm sorry. I'm just gonna put an any there for the moment, maybe, with a big to do. I do need like to do constrain two members of key purposes. ID, type, purpose. All right, all of that done. We can call this one ST key, and then instead of that, it's going to have base 64, which is data. All right. Oh, I'm looking forward to get back to the other work. We're working on coin join, where like the all of this type of stuff is done, and it's like, let's make it nice, let's make it so people can experience it better, and then other things, the RPC, P2P, ZMQ, DAPI. I'm looking forward to getting back to that. We have a nice piece of pie after this. All right. So once we've done that, sign transaction, identity, that's probably what that's supposed to say. So yes, we can, I mean, assuming that this were correct, we should be able to broadcast it. I don't want to do it tonight. Well, we still have to figure out the gRPC thing. So we're maybe we're halfway, maybe we're 2/3. The gRPC thing, I would think is not going to take that long. You know, but then I got to this and I was like, oh, okay, we've got WASM DPP. It's our shortcut. It's the thing that's going to save us. And then it turns out, no, because I don't know. I still don't know how to explain it. It's just implementing it both in Rust and in JavaScript in a way that requires you to have both Rust and JavaScript, but it's still doing the same thing in both of them. The JavaScript still does signing and the Rust does signing. The JavaScript does property setting and the Rust does property setting. There's no unique value. It's not duplicate code, like I'm going to write it in JavaScript and I'm going to write it in Rust. It's triplicate code because the JavaScript, I mean, aside from a few things, like, for example, the JavaScript, I'm not sure whether or not it has the state transition IDs or there's a bunch of type IDs that we went through, the levels, the transition types, the key types. I think there's 3 different hierarchies of type. So there's some of those constants that are literally numbers 1, 2, 3, 4 that are not duplicated. But the object structure is duplicated in both places. The setter and getters are duplicated in both places. It's just, I don't know how to explain it. I don't know if I could understand it if I weren't experiencing it. No, I could, because it's like I said, I would know it from, imagine that you took the Hello World conference slide for WASM and then you applied it to 1,000 lines of code. All right, Cbor. All right, so we've got the data there. That's looking good. Our purpose is 3 here. Purpose is 0 elsewhere. Security level is 0211. So I mean, I guess it makes sense to have a transfer key, like a designated transfer key. Okay, let's see if we can go backwards from this. Let's see what we get if we do CBOR to JSON online. What? Okay, so it looks like we went one way, we went the other way. Whether or not the types are encoded correctly, that's a different story. But at least it goes back and forth. Now, one thing I do find strange is that we ended up with these don't appear to be in lexicographical sort order. Yeah, they appear to be in random sort order, and that I find a little concerning. Because I thought that, is there like a canonical option? Maybe there's a canonical option for that node CBOR, and I need to turn on the canonical option. Okay, so there's also an undefined type. But let's see back here, didn't it say that this type was required? I think it did. Where's required? Required. Protocol version, type, asset proof lock, public keys. Okay, so on public keys, okay, required. ID, type, data, purpose, security level. Okay, so everything. 1, 2, 3, 4, 5 properties. Isn't that everything we have? 1, 2, 3, 4, 5, 6. Where did we go wrong? 1, 2, 3, security level data, read only. Read only is not required. Okay, so read-only is not required. That's optional. So let's go ahead and just take that away. All right, now let's look back at that CBOR again. Let's look for canonical. I'll be very sad. All right, so you have to turn on canonicalization. So how do we do it? Why would you make that optional? Encode canonical? Is this where we're at? Canonical true? Well, let's just try encode canonical and see what happens. That's very silly. But it would not do that by default. Okay. All right. I think null kind of serves the purpose of undefined. To define it as undefined, I think is poor form. It's not proper JSON. But whatever. All right, there we go. All right, good. So is it reverse lexicographical? It appears to be reverse lexicographical. I don't know about that. That makes me feel a little uneasy. Okay, so on the outside, type public keys. But on the inside, something doesn't quite match up here. I think maybe what we need to do is different. Maybe what we need to do is not encode one canonical, but do canonical true. Let's try that. and it could be doing some byte order that I'm not familiar with or is not intuitive to me. Okay. Yeah, this is not making any sense to me. This looks like BOGO sort. That's kind of a critical feature, I would think, of this. Is there a website for this where the docs are hosted, or what are we looking at here? No website. There's some docs. Let's try to find them on the web. That's weird. Okay, so there's docs, but they're not hosted anywhere? Encode undefined should be false. Okay, constructor. We don't need a constructor. I don't think. Oh, okay. All right, interesting. B needs to sort before double A. Very interesting. Okay, that's why it seems like BOGO sort. Okay, encode multiple objects. So we do need to run encode canonical. Wait. I want to pass more options. All right. Cbor. And maybe, what did I miss? What did I miss about this? So, new encoder. Where does encoder live? Encoder extends stream transform. I don't really want it stream transform. Yeah. What's the export here? Gen types, semantic types. Okay, so maybe I need to do... Okay, it says Seaboard is not a constructor. I'm a little confused. Okay, so exports encoder.encode. So let's check it out. Okay. After all, lexicographical sorts for ninnies. Ain't nobody need that. Right? Am I right? Oh. Let's move this key down here. And bring it back. Okay. All right. So it's doing something. It's just not intuitive to me. I don't know in what world comes T and then PU and then PR. I am not clear on that. I don't know. I don't understand it. I think they missed the mark on that one. It'd be interesting to see what their rationale is. Because normally you do lexicographical sort. Because you literally just sort the bytes. Okay, so with all that said, okay. So this would be one that's already on the chain, outpoint, public keys, signature. In theory, that's it. So what we'd have to do is we'd have to actually broadcast the transaction, which I have not wanted to do at this point. And we don't sign the message with the master key or any of these keys. We sign the message with the asset lock-proof key, which is otherwise known as the funding key. All right, so if that's all the case, which I don't know if it is. Oops. All right. So it's after 3 a.m. I'm gonna go to bed. Like I said, I think we're somewhere between halfway and 2/3 done on this as a demo to be able to get the basic identity. Then there's still work to clean it up from a demo to the beginnings of a library. We can take the stuff that we took out of WASM DPP, like these things, for example. Those move over into the library. A lot of the wallet stuff, we could create a wallet function that wraps -hd to work with at least the identity dip or identity derivation path. Let's see. Well, there's probably a few other things that we could do. And then, of course, we are not implementing any storage mechanism at all or any caching mechanism in this. I think we've done this enough times now that it's about time to put some earnest effort back into the wallet library, which does make those storage choices, so that we can use the wallet library and ask it for a key or whatever, give it an account. So basically we'd initialize the wallet library with this. It's for this code, it would be taking about maybe 20 lines of boilerplate out of the way, maybe. And then every time we needed to, we'd basically reserve address, commit address, reserve address, commit address. So you reserve addresses that you intend to use, and then you commit addresses once you use them. And the commit would basically just be not much different from the reservation, because the reservation is going to mark it as, hey, don't use this. And then we might also want to have some sort of metadata storage on the wallet, like a note for an address, a comment. And we probably want to have a way to have maybe a code, a comment and a code. Comment could be whatever we want to put there, regardless of the code. And the code would be a list that we grow over time with things like, well, this is actually an account and da 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 da. Or actually an identity. I'm definitely not doing a one-time use key. That's redunculous. You just lose the money if something goes wrong. Somebody could implement it that way, but I'm not going to implement it that way. I mean, one-time use, yes, but not randomly generated and then forgotten about. And, lost, money gets lost. All right. So yeah, I think we're good. Oh, wait, what happened? Oh, right. Maybe I should go ahead and publish this version. Oh, I gotta actually put in my physical key, not just my fingerprint. You get used to The biometrics, you know. All right, we're gonna do this again. All right, so what happened here was basically, I don't know. No, I had updated some the TypeScript types. So main was slightly ahead, and I didn't rebase properly first, and so. But now it's all cool. All right, so now over here we go back and we do package.json. There we are. There's a vulnerability. Oh, of course. Of course. So yeah, how could there be a vulnerability? It's in the gRPC code. Yeah, nothing we can do about it. All right, so all right, so that's where we're at. We might need to take out protocol version before we sign, depending on which is correct in terms of the documentation or which implementation. Keys look right. There's the extra payload there. Also not sure, you know, with the transaction that it was showing the wrong type. I'm guessing we just pick an Evo node and we connect to it via gRPC. I don't know. But I'm out. Adios.